Sorry about that.
Not a problem. Thank you. All right, so the recording has started, as well as the transcript. Like I mentioned, this is the tag meeting number 4 for Oregon. When I sent out the slide deck, the first page had Washington on it still, but this is the Oregon tag meeting. So we'll go ahead and jump into this. We have a lot of material. We moved distribution system planning from tag 4 to tag 5, so we may be able to get through this by lunch. We may go into the lunch hour if we still have a lot of information to discuss. At noon, we'll take an hour break and then we'll come back after lunch. So for the agenda, we'll do introductions here in a little bit, and then we'll have a safety moment. I'll touch on the stakeholder engagement document. We like to touch on that at every tag meeting. And then we'll have a presentation from Abby on IRP carbon update and assumptions. We'll have several presenters on renewable natural gas and hydrogen and our renewable gas programs. And then we'll have a presentation from the Energy Trust of Oregon on DSM. We'll share some preliminary results, and then we will wrap it up with the remainder of the timeline and the next steps. So we'll do introductions, and I'll just go down the list. First, I'll introduce myself. I'm the supervisor of resource planning here with Cascade. So we'll jump to Abe.
Hi, Abe Abdallah from Oregon Public Utility Commission.
Thanks, Abe.
You.
Pam.
Pam Archer, Cascade Regulatory Affairs.
Thanks, Pam. Lori.
Good morning, Lori Blattner, Director of Regulatory Affairs for Cascade and Intermountain.
Thanks, Lori. Bruce. Are you there, Bruce?
Yes, I am. Can you not hear me?
We can hear you now.
Okay. Bruce Folsom, IRP consultant to Cascade Natural Gas.
Thank you, Bruce. Kathleen.
Hey there, Kathleen Campbell. I'm a senior engineer with engineering services for Montana Dakota's utility group.
Thank you. Kevin.
Good morning, everybody. Kevin Connell, Director of Gas Supply and Gas Control for Cascade.
Kevin. Monica.
Good morning, Monica Kalashaw. I manage energy efficiency programs for Cascade.
Thanks, Monica. Kent.
Good morning, Kent Krause. I'm manager of industrial services for Cascade, and I manage the company's renewable natural gas and hydrogen development. Thank you.
Thank you. Ashton.
All right. Hey, good morning, everyone. My name is Ashton Michael Davis. I am a resource planning economist with Cascade.
Thanks, Ashton. Brian.
This is Brian Hoyle, accounting for Cascade.
Hai Xiao.
Yeah, my name is Hai Xiao Huang, economist from Northwestern Natural. Thank you.
Thank you. Kathy.
Oh, did you just skip Abby?
On my list,
Kathy Moyd. I'm following for the League of Women Voters, participating here as an individual.
Thanks, Kathy.
League of Women Voters of Oregon.
Thank you. Abby.
Yeah, it wasn't in alphabetical order or something there. Abby Krebsbach, I'm our environmental director at Cascade MDU.
Thank you. Kyle.
Hey, good morning. Kyle Morrill with Energy Trust of Oregon.
Thanks, Kyle. Devin.
Hey, good morning, everyone. Devin McGreal. Oh, my camera's not working. There we go. Devin McGreal, Senior Resource Planning Economist with Cascade.
Thanks, Devin. Mike.
Good morning, everyone. Mike Parvin, Regulatory Cascades Regulatory Team.
Thanks,
Morning.
Mike. Caleb.
Yeah, good morning. Caleb Reimer, Economic Analyst with Cascades Energy Efficient Department.
Thanks, Caleb. Mark.
Good morning, everyone. Mark Solis Vaughn, manage the integrated resource planning process.
Thanks, Mark. Carolyn.
Carolyn Stone, Cascade Natural Gas Supply.
Thanks, Carolyn. And Eric.
Yeah, good morning. Eric Wood here, Supervisor Gas Supply for Cascade.
Thanks, Eric. And I think I saw Kim, you joined?
I did. Sorry, I'm late. Kim Herb with the Oregon Public Utility Commission.
Thank you. And is there anyone else who joined? I don't see any extra names, but oh, Chris just joined. We're doing introductions. Chris, if you want to introduce yourself.
All right, thanks. Sorry I'm late. Chris Robbins with Cascades Gas Supply and Gas Control Groups. Thanks.
Thanks, Chris. All right, I think that's everyone. So we'll jump into the safety moment for today's presentation. So today's safety moment is preventing eye strain. I know there's quite a few of us that are on our computers 8-10 hours a day. So we want to make sure you prevent any eye strain. So make sure you keep your screens at arm's length. Don't forget to blink. Make sure you're blinking. And follow the 20-20-20 rule. This is where you take a break every 20 minutes by looking at something at least 20 feet away for at least 20 seconds. That'll reset your eyes, and then you can go back to looking at your screen. Be mindful of lighting and glare. Make sure your screen isn't too bright. Adjust your computer monitor properly, and that'll help with neck strain as well as preventing eye strain. And then increase your computer's type size if you need to. And then there's some more information if you click on these links or go to these links on preventing eye strain. If there's any other information that you need. And then stakeholder engagement document. For those who aren't familiar with it, we have a stakeholder engagement document. This helps provide kind of commitments from Cascade as well as our expectations from stakeholders. We have some primary the rules and commitments that we want to make, and some of those are have a quality stakeholder engagement process, and it requires an iterative process, collaboration, and commitment from everyone involved. Inputs from diverse perspectives improves the resulting IRP tremendously, and we look forward to hearing everyone's perspective during these meetings. This is another reminder, if you have questions, you can put them in chat, you can raise your hand, you can interrupt us at any point during the presentation to shoot us your question. We try to remove any barriers to participation in communicating in clear language with solid data. We record these presentations, we put them out on the website, so feel free to go back and look at old meetings. We put out meeting minutes as well if you want a brief reminder of what the meeting was about. And then transparency. We try to be very transparent. We make ourselves available if needed. If you have any questions, reach out to us. We'll set up a meeting if we need to walk through anything. So please feel free to reach out to us. Our information is at the end of this presentation. And we've had questions, what is a stakeholder and can I join this? And the answer is yes, anyone can join this. If there's someone watching this this recording later and you want to join, feel free to reach out to me. We can get you on the distribution list. Stakeholders are basically customers and the general public participating in the IRP process. It also includes professional analytical staffs of the state utility commissions and groups representing residential industrial customers, and like Kathy, League of Women Voters, are also involved in our IRP. So we thank everyone that has joined us, and we are open to more people joining if you are interested. And then there's a link down here to our Oregon IRP webpage. We have one for Washington as well. So feel free to look at both. And we're always looking for feedback on the IRP website. If you have any edits you'd like to see, any additional information, feel free to send that our way. All right, with that said, I'm going to pass this over to Abby.
All right. Thank you, Brian. And Brian, if anybody raises their hand for questions or pops something in the chat, please let me know and I'll pause there for a question. Thank you. So thanks. Yep. Providing that IRP carbon update here. So the things I'm going to cover at this meeting are talking a little bit about our base case projections of emissions from our base case sales, showing those, and then talking about our emissions reductions and our commitments to those reductions. And then a little bit about policy that we have that applies to us, especially in Oregon, the Climate Protection Program, and ways we would reduce emissions in order to comply with that program. And then I'm going to pass it back over to Brian for a little bit for the local focus. And then he's passing it back to me for the national focus to discuss. And then I'll go through a little bit of the Washington, Oregon differences and then next steps. Thanks. Next slide. Okay, so wanting to just really highlight our commitment to reducing emissions. As an energy provider proudly serving Washington and Oregon, Cascade Natural Gas has an important role in securing a lower carbon future for the Pacific Northwest. And natural gas remains the cleanest option to meeting the region's peak energy demand. This means keeping Cascade's system reliable and affordable and resilient for our customers while helping communities meet their emissions reduction targets and needs. So communities and agency programs where we see focuses right now, Bend, Bellingham, Whatcom County, some of the communities that have created climate action plans. And then of course we have the Oregon CPP, Climate Protection Program, and the Washington Climate Commitment Act that is due to be final by about early November here. Our environmental policy is that we would operate efficiently to meet the needs of the present without compromising the ability of future generations to meet their own needs. And our goals are listed here: minimizing waste and maximizing resources, being a good steward of the environment while providing high quality and reasonably priced products and services. And we strive to comply with or surpass all applicable environmental laws, regulations, and permit requirements. Okay, next slide. So when you look at this chart here, these are our emissions that have been translated from our projected gas sales. When you look at 2023 and on, 2022 kind of being about similar to 2023 there, although that's not listed on the chart, just because we don't have actual emissions yet. I think Kathy Moyd has a question. I can pause here, but there were a number of things I was going to talk about with this slide. So I don't know if you wanted to wait until the end of the slide or if you have a question now.
My question is mainly dealing with the natural gas from the electric generating plants. You still have to report those to the DEQ, don't you? Those
Oh,
emissions?
yes. Yeah, we still report them, but they're taken out of our compliance obligation. So as you see here, the emissions in the past have been meant to just show what that difference is in those emissions that we see from electrics. And I took those out for the projections and future. Yep.
No, I realized that was one of the contentious things in the developing the climate protection program, and because of HB 2021, it was considered that we didn't have to do it under the CPP.
Right. So those emissions from electric generating plants are totally excluded from the CPP. Any plant that's less than or equal to 25 megawatts. Yep. Yep.
Right.
Yep. So this is just a snapshot of what our traditional natural gas delivery emissions would be. And also consider that in that yellow bar at the top, those are our transport customers, as well as the rule in Oregon requires us to be the covered entity and obligated to comply with our transport customer emissions as well. Okay, next slide. So ways in which we have been reducing our customer emissions are through energy efficiency and conservation and demand side management. Monica Colshaw and her group are going to be talking about these emissions reduction, or focusing on what programs we have implemented in her presentation here today. But we have had some increasing focus on energy efficiency and benchmarking and all of these programs, including commercial program adaptation, excuse me. We have adopted and adapted these programs to meet our increased goals. And we're also exploring opportunities with our transport customers. As I said in the last slide, that's a new thing for us. We want to be able to work with them to realize emissions, because a lot of, a big chunk of our emissions obligation is with those customers. So when you look at Oregon emissions reductions through EE and conservation programs over the past 3 years, it is between about 2,500 to almost 3,000 metric tons equivalent emissions reductions each year. And when you're looking at total of those years as they are additive to each other, it ends up being in the range of about 8,000 tons, I think, of emissions reductions. And that's something that I would like to explore a little bit further, and looking at over time, how do we see those stacked onto each other for those emissions reductions we're seeing. Washington is a little bit larger, customer base, so you're seeing some additional emissions reductions there. But we've really had a lot of success with our programs in Oregon. For the amount of customers we have, it's when comparing the two states, Oregon has really had good support. So the other way in which we're looking at reducing customer emissions is through RNG projects, renewable natural gas. Others are going to be talking about that today at this presentation, and I will defer to them, but we are engaging in discussions with several developers and projects, as well as looking at purchasing environmental attributes for our customer compliance needs in Oregon. And those RNG deliveries from those specific projects wouldn't be able to start until about mid-2024. So it's essential we have those attributes for compliance. So if you can go to the next slide. We have committed to emissions reductions and data gathering for natural gas distribution operations, our methane emissions and pipeline infrastructure. And also I'll say we have combustion equipment here, but we don't have any combustion equipment like we have in Washington. So it's mostly fugitive emissions that are in our calculations here. We have about 8,000 metric tons per year of CO2e that we have reported to both Oregon DEQ and EPA according to their requirements. And there are amendments to an EPA rule that Oregon incorporates kind of by reference that could change how we calculate those emissions from our system and operations. There are emission factor changes that we could see, and the requirement to report these other large release events, which currently aren't reported now to EPA. Those are like excavation damages, those kinds of emissions, or other maintenance blowdown events, those kinds of things. And those, if that event would be over 250 metric tons of CO2 equivalent, then we would have to report those to EPA. That's proposed right now. And we don't know what that final rule is going to be. I think comments are due here pretty soon in September or October. And a final rule could be seen by later this year. And then this would apply to emissions that we would start collecting and reporting as of next year in 2023. So when you look at the other operational emissions that would be added into our inventory beyond that 8,000 that I mentioned in that first bullet, where that's what EPA requires to report, we estimate that when you add in everything, it's probably going to be in the range of about 11 to 16,000 metric tons per year of CO2e. It really depends on the type of protocol you use. There are different ones out there and they have different emission factors. Some allow more company specific emission factors, which we are hopeful that could come out of the EPA rule. We want to try to get a more accurate emissions inventory with some of what we know company specific wise versus just using a default emission factor that wouldn't represent what we do at Cascade. If you look at our emissions, that 8,000 to kind of 16,000 metric tons, if you take that and look at it from a methane emissions release per methane throughput, our emission rate is very small. It's 0.07% of methane emissions per what we deliver to customers in that 0.07 to 0.11% range. And we're right in line with the goal of what One Future companies strive to hit. They actually have a goal of about 0.22%, and we're way below that. And what One Future companies in a 2020 report stated was that they've achieved about 0.092% emissions. So we're right in line with that. We're happy to say that we're with that group that really focuses on those things, and because we're doing the same. Okay, next slide. Some of the ways in which we are looking at operational emissions reductions are through our membership as a founding member of the EPA's Natural Gas Star Methane Challenge Program. And we joined that in March of 2016, and we're specifically participating in excavation damages. We have created a public awareness coordinator position and implemented a damage prevention program, which has resulted in decreasing trends in emissions, mostly related to how we're tracking, how we track awareness and one call, increases in people calling one call, and then translating that to actual hit events. And we actively participate in 811 Common Ground Alliance, local underground utility coordinating councils, and have damage complaint programs in both Washington and Oregon. We analyze those excavation damages and report data to EPA. We have created and developed a more robust inventory of greenhouse gas emissions in all of our operations for this year that we would compile by the end of this year to know in early 2023 what those would look like. And an example of how we have done that, expanded that data collection, is increased our internal reporting of gas losses to include even much smaller non-hazardous releases, but to get a more robust inventory. We also mitigate methane leaks and expedite the mitigation of those leaks. We've adopted a program to quickly address those even small leaks that are considered not considered a public safety concern. And we're exploring ways to reduce emissions in our normal operations, including the use of methane capture equipment or technology for pipeline blowdowns. There are technologies out there that are a couple trade names, GoVac, I think, and ZVac units, where during a routine maintenance where you might normally blow down a pipeline, take it out of service and blow it down, there's a chance that we could utilize equipment to actually capture those emissions and re-inject it into the pipeline. So we're looking at doing some pilots of that, or a pilot of that in the future, to understand how we may adopt some kind of practice into our system and operations. But that's one thing we're looking at. And I see Kathy has a question.
I realize this is probably a little bit off the wall, but are you looking into, it's my understanding that there's actually, I think, going to be a satellite that's going to be able to identify methane releases. Are you planning on using that data or any airplane surveillance to detect methane leaks that you might not otherwise know about?
I have not explored that. We have not explored that to the best of my knowledge, but it's good to be aware of that. I appreciate knowing that, Kathy. There are
well, then NASA has been doing with a plane for a number of years.
Yeah, I think to identify something rather large that could be occurring, that's super useful, I think. But when we talk to our counterparts in other states like California, where I think SoCalGas has adopted programs and has approval through their commission to go out and actually survey their areas. I think there's a combination of what you would want to do there, whether it's like an aerial vehicle, but then you might be catching something that's not at all related to natural gas pipelines. There are so many other sources that you catch in those kinds of reviews. And so once you start looking for them, you can't necessarily assume that they're from one source or another, and you have to go in and actually do some more specific on the ground surveillance to determine. And to do that, there is an additional cost. So something that we're looking at how others are doing at this point, but definitely looking at tracking more data of what we actually do in the field so that we can get better estimates of what we might be emitting.
Okay, thank you.
Thanks.
I had something quick. We do aerial leak survey. Intermountain Gas does it. There's some large laterals, for instance, parts of the Sun Valley lateral that runs from Twin Falls up to Sun Valley, about 70 miles. We do aerial surveys on that. So they fly with helicopters and do RMLD, I think. But yeah, so we do it in the utility group, and it's actually more cost effective than walking it. It's just because it's remote. In Oregon, we don't have those pipelines that are as long and as remote. But just some information for you guys.
Perfect. Thanks, Kathleen. Okay, next slide, Brian. Other ways we've been reducing our emissions is through replacement of older vintage steel pipe, older materials with newer vintage steel pipe. And so through these system integrity projects since 2012, we've replaced about 45 miles of early vintage steel pipe. And in Oregon, excuse me, a new steel pipe or polyethylene pipe that are lower leak prone and less emitting. And in Washington, that's about 98 miles that we've replaced. And we are better positioned than most in the U.S. utilities in that we have newer systems that have no unprotected steel or cast iron pipe, where those are more leak prone. And so when you see other companies replacing those types of pipeline materials, you have further leak reductions, but we didn't have those to begin with. So next slide. Okay. Just wanted to talk about the climate protection program, as that's currently in place and we are complying with it. So that program was established by DEQ through Governor Brown's Executive Order 20-04 to reduce greenhouse gas emissions, not only from natural gas utilities, but like across the entire economy of Oregon. Governor Brown had agencies look at across the board, look at where emissions reductions could be achieved. But the CPP in particular applies a declining cap on emissions from certain covered entities, then establishes a program to track, verify, and enforce compliance with the cap through the use of compliance instruments. And I will go through all of this as quickly as I can here. Fuel suppliers, natural gas suppliers, and large industrial facilities. And those large industrial facilities are regulated or covered for just their non-natural gas fuel use, and process emissions. All the natural gas use from those large industrial facilities, again, I talked about our transport customer emissions, those are regulated at Cascade as a natural gas supplier. So those are the covered entities under the rule. The emissions reduction targets are 50% reduction by 2035 and 90% reduction by 2050. Some of the excluded, next slide, Brian. Yeah, excluded emissions and sources are natural gas operation emissions. So thinking about that 8,000 to 16,000-ish tons of per year that we have on our system for emissions, those are excluded. Emissions from biomass derived fuels are excluded. Emissions from non-combustion use of natural gas, if that is approved by DEQ, those are excluded. And then of course we talked about the any natural gas use from electric generating plants greater than or equal to 25 megawatts, those are excluded from the rule. So when you look at our customer emissions in 2023, that's about 800,000 metric tons of CO2e in 2023. And that represents, again, all our core customer emissions and non-core, again, excluding electric gen. And when you look at our operational emissions in that 8,000 to 16,000 range, it's, you know, that's pretty small when you're looking at the emissions from our combined customer base. It's like in the range of 1 to 2%. Okay, next slide. Our baseline emissions were generated from our 2017 to 2019 average of natural gas sales converted to emissions. And those decline over time according to the 50% reduction from baseline of 2030 or by 2035, and then by 90% of that baseline by 2050. So you can see that in the graph to the right. These represent, everything underneath that line represents our compliance instruments that would be allocated to us from DEQ, and those again decline with the trajectory presented here. I might refer to those as allowances. So similar to Washington, we are given allowances to a certain amount. DEQ and Oregon gives us some allowances. And we are given these allowances each year. DEQ puts them into our program account at each March of every year. Okay, next slide. We have started the rule already. It started in January of this year. There are 3-year compliance periods. 2022 to 2024 is the first compliance period with 3 years ongoing thereafter. We have to demonstrate compliance with that first 3-year period by November 28th of 2025. So it's every November 28th after the year following the end of a compliance period, you have to demonstrate compliance and submit to DEQ compliance instruments to meet that your emissions obligation. Or I will talk about some other ways in which we can comply with the rule rather just other than allowance or compliance instruments that DEQ provides. Next slide. We have renewable natural gas, which is basically a 1-for-1 replacement of traditional natural gas. Hydrogen is a future option that we're modeling. And again, allowances or compliance instruments, we have those. Again, they decline over time. There are unlimited banking of those allowances. And there's a potential that they could be traded between covered entities if a covered entity would make more emissions reductions in the near term. They might offer those to be traded, but that's really unknown at this point. There's energy efficiency and conservation and demand side management program adoptions that we could implement. And then there are community climate investment credits that we could purchase. There are kind of DEQ's option of like a credit that you could purchase. Those are limited for use. We can use 10% of our compliance obligation to be met by these CCIs in period 1, and then period 2 that increases to 50% of our obligation, and then in 3 and thereafter it's 20% of our compliance obligation that we could use for CCI credits. You don't have to buy CCI credits, but they are available if needed. And you can only bank them for about 2 compliance periods, and then they expire. And I think Kathy has a question.
Just a couple of things. The potential for trading meat is allowed between covered entities, but I assume the unknown is whether anybody's going to want to participate in that. So I did notice that as a question mark in one of your slides later, but I see that you've covered it a little bit more explicitly here is what the unknown is.
Yeah, the unknown is whether those would be available.
Yeah.
Be available from another entity. Yeah, whether they would be comfortable selling those. Yep.
Yeah, they did. They did leave those as being usable indefinitely. The feeling was that the CCIs shouldn't be allowed to be saved up till the end of the time period.
Yep. So that's a limit of 2 compliance periods that I recall that you can use those. Are you saying that you've seen differently?
Well, no, that was one of the things that was put in at the last minute, based on, I think, comments from some of us.
Okay. Any other questions,
Yeah, there were
Kathy?
a lot of changes made after the draft proposal before it actually got to the Environmental Quality Commission for approval.
Okay. Thanks, Kathy. Any other questions? Okay, next slide. Okay, just talking about our compliance options in regards to renewable natural gas and hydrogen and how we're modeling those. We do limit in our modeling the amount of RNG based on a company potential share of RNG projected based on 2019 AGF ICF study values, based on what our emissions are within the state of Oregon compared to the other LDCs. And the 2019 AGF study provides RNG potential by 2040 and adoption curves that we're applying for the various types of RNG and pricing. And so we're using that to generate our acquisition curves for each resource. And then for hydrogen, we're basing and constraining our hydrogen maximum on the amount that could be safely, that we know right now that would be safely blended with natural gas. And we, one thing to note there is that if somebody, if there's a focus on providing just hydrogen to a location, that could change potential in future with how we would model hydrogen. If it's a direct source hydrogen kind of request or something, that's something that we'll be thinking about. And it would change just our assumptions a little bit, but right now this is what we're assuming. It's a blend. And according to GTI reports, if less than 20% hydrogen is introduced into a distribution system, the overall risk is not significant for both distribution mains, lines, and services. So hydrogen itself, and just going on here, the National Renewable Energy Laboratory research findings also indicate that adding hydrogen blends at a 20% or less to a system of natural gas would result in only minor increases in safety risk. So what you learn from those statements is that you can have this blend, but there might be some other things that we need to adopt. We might have to monitor our system a little bit differently because hydrogen is a little bit different characteristics than natural gas. Is there more of a leak potential? Then you have to look at just monitoring certain pieces of your system a little bit more. And there's also the ensuring that that percent blend is acceptable for customer appliances. So at this blend, it's assumed to be okay and can be used in existing appliances. If you're looking at higher hydrogen blends, and we're looking at studies that might come out in the future on how that works with appliances, you could, you want to watch what that blend is to ensure that you're meeting the customer needs on the end use piece. And note that this is a volumetric quantity. Hydrogen burns at a lower heating value. And all our modeling is done in therms versus volume. So we adjusted that volume to energy, and where that energy blend is at a 7% energy blend versus 20% volume blend. So next slide. Just a little bit more on CCIs. Those are, there are costs that are specifically applied to CCIs that DEQ specifies. There's an equation in the rule noted here where CCIs start at a certain amount, and then you have to apply inflation factors to those over time, where the first year, 2023, we might have in the range of like $114 per metric ton cost of a CCI. And then that would increase over time too. Right now we have it projected maybe at 2050, it might be $400 a ton. Depending on the inflation factors that we're seeing now, that could be higher. So we'll just monitor that as we go. But that would be the cost of a community climate credit investment credit. Next slide. I just threw this together just to show you a compliance schedule that we would see in the next few years, especially this first compliance period. So in January, we have the rule, it's effective. We received our distribution of compliance instruments from DEQ in March, and our annual emissions reports are due by March 31st of each year. We are also required to verify our emissions that we report in March. So we have conducted those verification processes and just did that at the end of August and submitted that. Going into 2023, that's really where we will report in March our emissions from 2022, which is our first regulated year of emissions. And again, it kind of follows the same line of where you're going to get your compliance instruments distributed for 2023 in March, go through verification processes, and it's possible that we would be given the opportunity to buy CCI credits potentially by about mid-2023, depending on how many entities have been approved through DEQ's programs. Recently, DEQ submitted or released some dates of which they were going to have some training sessions on CCIs and how those would be purchased, I believe. So we've signed up for those. I think they're coming up here in the near future, maybe later in September, early October. Those are happening. And then the process continues. And then by the end of 2025, which is that November 28th of 2025 is where we would have to supply all of our compliance instruments or CCIs we purchased to ensure that we're covering any emissions obligations that we would have. And next slide. Just a projection here for what we're seeing for compliance options that we would be purchasing. We have by 2025, and again, when you look at blue, this is just RNG and hydrogen. The blue is Washington. Let's focus on the orange and the yellow here. So the orange is the amount of RNG decatherms that we would be purchasing for compliance in Oregon. And the yellow would be the projection for hydrogen. I think we're pushing that out to 2030 possibly. And I'm going to defer to Devin on that, but we do see that already in 2025 here, but that could be pushed out, which means we're looking at more RNG and environmental attribute purchases for that first compliance period, and that just grows over time. Was there a question from the audience? Okay.
I think Kathy had a question.
You covered it by saying environmental attributes. I'm not personally enthusiastic about the ability to use those, but I realize that Oregon does let you do that.
Yeah, it's consistent across many of the different programs within the Pacific Northwest states. And it's really essential that we have the same types of consideration in those, especially when you look at how electric entities can also utilize RECs for compliance. It's a similar concept. Okay, next slide. And I'm going to pass it off to Brian so he can talk through the local items, and then I'll come back for the national. Okay.
All right. Thanks, Abby. So yeah, we have some local focus GHG emission reductions. We have different types of them in our service territory. We have specifically in Oregon, we have the city of Bend. They have some aspirational goals and to reduce GHG emissions by 40% by 2030, based on 4 areas of focus. And this is from their Bend Climate Action Plan. The first is energy supply, transportation, energy and buildings, and then waste and materials. There isn't really a specific carve out when we were meeting with the city of Bend when they had their climate action plan group meetings. So there wasn't a specific carve out for what Cascade was required to do. However, Cascade, a representative at the steering committee, helped identify pathways for gas to support the city goals through development of an offset program, as well as a biodigester plant, which we actually were awarded a Bend landfill, which kind of takes place of that biodigester plant. The city's current environmental and climate committee is having preliminary discussions about the role of gaseous fuels as part of decarbonized future. And Cascade intends to share information on its emerging RNG efforts and overall renewable gas potential as appropriate. And we've continued to communicate with the city of Bend, and we're going to increase the communication between the city of Bend and Cascade. We'll be meeting with them with ongoing check-ins to make sure that we are best supporting their efforts for what they are needing to do in the city of Bend. Yes, Kim, you have a question?
Thanks, Brian. Yeah, I mean, this is something that I think we're really interested in staying on top of and understanding sort of what those communications are like. Is there like you're capturing minutes for this, I mean, is it possible to share what's being communicated to that committee and how frequently that committee is meeting and when you guys are plugging in with them?
Yeah, so we actually met, not we, Alan Spector, he's not on this call. And I'm blanking on the name of the representative with the city of Bend, but he met with a representative with the city of Bend just to chat about the Bend Action Climate Plan and discuss our understanding of what we got from the Bend Action Climate Plan. And we've set up a meeting. I think the resource planning team are going to meet with the city of Bend mid-October, and we plan to have bi-weekly. So every other week we'll be meeting with them. We may change that to once a month if meeting every other week is too often. But right now we're going to start meeting every other week, we're going to, I think the first kickoff meeting we'll kind of talk about the Bend Climate Action Plan and what their expectations are for Cascade. And we'll definitely share some of our communication efforts in the actual narrative of the IRP.
Great. Okay, that would be great. And we'll just maybe communicate with you guys,
Yeah.
regularly on that, just because this is such a space of, evolving strategy, and just want to make sure that we're all aligned.
Definitely. Yep.
Cool. Thank you.
Yeah, thank you. So the city of Bellingham, they passed an ordinance on February 7th, 2022, so earlier this year, which requires electric space and water heating equipment for new commercial and large buildings. It also requires incremental improvements in EE and solar installation or readiness in new buildings. So this electric only mandate is for space and water heating. It does not apply to single family construction, detached houses, duplexes, or town homes or row houses. The ordinance did take effect back in August 7th. And one other thing about this is it is within the city of Bellingham city limits. And so that's something that we have to keep in mind. We weren't exactly sure how to implement this ban in our modeling, mainly because there were some questions about if a customer really wanted to go into the city of Bend or city of Bellingham, they could still potentially do it outside of the city limits and still be on our distribution system. But what we did to run a sensitivity analysis is we looked at data from 2017 to 2021 to see which customers would have been affected by this ban if it took place earlier. And it resulted in about 50 customers a year. So what we've done is we've done a sensitivity analysis where we've decremented the customer count cumulatively by 50 each year in the city of Bend, just to see what kind of impact that would have on our demand and our upstream modeling.
Brian, just to clarify, that was Bellingham, not Bend.
Yes, this is Bellingham. Yes, Kim, you have a question?
Yeah, I'd be also interested in hearing more about the sensitivities that you're crafting for this. I think it's helpful to understand, if there are, similar gas bans that take place in other cities, how to think about that or prepare for that. So I will be interested to see sort of how you're modeling out that sensitivity for this.
Yeah, definitely. Yeah, and we should have we'll definitely have more information on these bans in tag 5 when we go in depth about our scenario modeling and the results of those scenario models.
Great.
Yeah.
Thank you.
Yeah. So a little more information on the city of Bend continues to work on the design of a climate action fund. Preliminary drafts indicate that this would be treated as a property tax and would direct funds towards electrification, among other efforts. Following the city council and mayor expressing reservations about the design and timing of the plan, it was announced they'll likely delay putting the measure on the November ballot. So that's something that we're definitely keeping an eye on. And then Whatcom County, they voted to ban the construction of new refineries, coal-fired power plants, and other fossil fuel-related infrastructure. This doesn't quite constitute as a gas ban, but it may have impacts on our distribution system enhancement projects if they're needed in Whatcom County. So that's definitely something we're keeping an eye on. And I see, Kim, you still have your hand up. Do you have another question?
I do not.
No problem.
Thanks.
All right, and I'm going to kick it back over to Abby for the national focus.
Yeah, just a few more slides in our section here. So just a number of things that we're looking at and just monitoring for the most part, but U.S. Department of Energy is in the process of holding proposed rulemaking for energy conservation standards for commercial water heating equipment. This rulemaking may result in impacts to baseline equipment used to determine our energy efficiency portfolios. The same agency has also launched a notice of intent for funding opportunities for clean hydrogen programs associated with the bipartisan infrastructure law. And Cascade is also monitoring for opportunities for any partnerships or any engagement we might want to take advantage of, I guess, in that sector for our sector across the states we serve. EPA, I've mentioned this already, they announced these amendments to the Subpart W, which is the oil and gas segment, our fugitive emissions and combustion emissions from our operations, those emissions. They're proposing emission factor updates and the reporting of these other large release events. That rule is expected to be final probably by the end of the year, and that would impact what we would start compiling, collecting for 2023. But we've implemented programs already where we think we're probably capturing a lot of that emissions now in 2022. So we should be good to go there if that is finalized the way it was proposed. The U.S. Supreme Court issued its decision on July 1st for the West Virginia versus EPA ruling, where that was meant to issue a decision. The court was issuing a decision on the extent of EPA's regulation of greenhouse gases from the electric sector and those power plants. And they have limited how EPA can regulate emissions underneath those types of rules. We're expecting EPA to propose new regulation in 2023. Most recently, they opened a docket requesting more information about how they would approach this type of regulation. So we're wondering if that regulation timing would be pushed out a bit, because the docket, I think, is open until sometime in early 2023. So it might not give them enough time to propose a rule of when we first thought they would. And we'll be monitoring that future rulemaking. It could impact the low carbon fuel requirements for units to be, for new units that are constructed, and which could impact what we might provide to electric generating units in future. The Inflation Reduction Act passed on August 16th and was signed into law. It includes climate change investments to promote decarbonizing the economy. There's also a methane emissions reduction program included in the law, which would require fees or investments to reduce methane emissions. And those are mostly applied to the upstream oil and gas value chain. And to the best of our review of this law at this point, that none of the natural gas value chain emissions or operational emissions for our distribution system would be included in that. But if others upstream of us would need to pay methane fees or make reductions, that could increase the costs that we would have for supply of that natural gas. Next slide. I think we might just a really quick differing policy comparison between Washington and Oregon. And a lot of, I'm just going to go down these items here and just talk a little bit about the differences. So RNG, environmental attributes, are kind of a question mark right now in Washington. The current drafted rule and reporting rule don't recognize the ability to purchase attributes. However, the Washington UTC policy guidance on RNG programs for customers does reference and recognize those for compliance, and Oregon CPP recognizes those for compliance. Oregon LCFS, Washington LCFS rules, Oregon OAR 86150, which is the SB 98 rule under the PUC, recognizes environmental attribute use for compliance. from what we read. And California programs all provide use of environmental attributes for compliance. So we're hopeful that Washington will adopt their rule in November with that acceptance. Then we can buy project-specific biogas that's delivered directly onto our system, and coupled with those environmental attributes, that's allowed in all areas. There are these no-cost allowance allocations, which in Oregon I refer to as compliance instruments. Those are provided in both programs. Oregon doesn't have an auction to purchase additional allowances. Washington does. Allowance trades between covered entities. I have it again, Kathy's question before, I have it as a question mark here, basically just saying, I'm not sure what the ability or what the likelihood of that would be, even if, we're able to do it. So we'll see how we do. Environmental offsets are allowed for Washington compliance, and the Oregon CPP, there are no environmental offsets allowed. Instead, there's community climate investment credits that are allowed in Oregon, which Washington doesn't have a similar program, but they have the offsets. Energy efficiency and conservation can be used across, and so can hydrogen. And the differences with compliance options across the states we serve are anticipated to create some challenges with compliance planning. We've had some really complex conversations with a number of our departments and planning for compliance with all these differences. But limiting RNG to demonstrating contractual delivery, talking about that environmental attribute piece, so limiting it to that contractual delivery we just see as misaligned with the other states and agencies' determinations, and really overlooks that recognition of how electric RECs are considered and can be used for compliance within their areas. So we're hopeful that that becomes more consistent and then provides our customers with a more reasonable cost compliance option across the board. And it'll save money for us trying to figure out which different things can be used for different programs if it's more aligned. With that, I'll go on to the next slide. Just some next steps for compliance planning demonstrations for Oregon CPP in particular, kind of protection program. Really working with other LDCs and the OPUC on regulatory mechanisms that we need to have in place in order to successfully comply with the program and purchase compliance instruments for customers. One good example is just being able to provide emission reduction compliance options for our transport customers. And then we continue to pay close attention to all these differing regulatory requirements, national, regional, local, that relate to carbon. And then we will be providing a more update on the modeling impacts for Tag 5. We will be providing more information about scenarios and things like that. So I think Kim may have had a question. Yep.
Thanks, Abby. I just had a question about the national policies, and one thing that I don't think I saw on your slide was the Securities and Exchange Commission's task force on climate-related financial disclosures. Yeah, is that something that's on your guys' radar?
Yeah, that was, I apologize. That was in my notes actually for the Washington one, and I forgot to put it in my notes for this one. Yeah, definitely. So we're looking at all of our data collection efforts and how we're approaching any kind of climate reduction goals setting in through that lens too. It's going to be different. And so that rule would be final maybe by year end. And we don't know what exactly that's going to look like in final form. There's a lot of speculation, but yes, it is definitely something we have on our radar and we're planning for.
Great, thank you.
Yep. Thanks for the questions. All right, with that, if there aren't any more, I do see a hand up, and that might be Kim still, but nope, it's not Kim. It might be somebody else.
It's Abe Abdallah here from Public Utility Commission. I just wondered if you're going to show in Tag 5 or tell us a bit about how do the compliance instruments used going to look against the compliance period targets, because I see in slide 21 that the RNG and hydrogen potential is constant, almost constant, going all the way through from 2037, 2050. Does that mean that you'll be using other measures to compensate for because obviously the target will be higher in those higher years? So does that mean you're going to be using other, or is that something that you're going to address in TAC 5?
Hey, this is Brian. Just a clarification on this slide. This is what we see as RNG and hydrogen potential, not necessarily what we're going to be purchasing. And then in tag 5, we will have more information. But further on in this tag presentation, in the preliminary results, we show a preliminary like results graph that shows how we meet emissions through CCIs and RNG and hydrogen.
So you will have that graph showing how you're going to meet the targets?
Yes.
Okay, thank you.
Yep. All right. Thanks, Abby. Are there any other? Oh, go ahead.
Yeah, there is one in the chat from Kara Saylor, I think. And this might actually be better answered from Lori, who's on the phone here. But she says, Kara says, apologies if you answered this and I missed it, but would love to know a little more about what opportunities you're exploring with transport customers for CPP compliance. So some of those would be RNG, renewable natural gas options. I mean, that's always something, but really energy efficiency program adoptions and the potential energy efficiency improvements that might be made at those facilities. That's something we're really wanting to focus on, and we're starting that effort. So I don't know if Lori and Monica, you have your hand up. Maybe you have something else to add to that.
So Abby, I can take a crack at that, and I guess it was sort of in the presentation later, but it's probably fine to address it now too. So what we're looking at for transport customers on the energy efficiency side of things, and we've talked a little bit with the ETO folks, a little bit with AWEC. This project is still kind of in development, but we think that we need to get a good feel for what energy efficiency potential is out there for transport customers. And so, one method would be to do a conservation potential assessment. We don't have a huge number of customers in Oregon. There's, I think there's about between 35 and 40 total. And so it seemed to us like it might make sense to do a more customer specific sort of analysis. Our working description is a carbon compliance assessment. And what it would look like, kind of in broad terms, is to start with looking at what sorts of things, so hiring a consultant and having them come in and work with each facility individually to identify 3 different levels of savings. So the first level would be things that would be easy for the plants to do themselves, simple behavioral type stuff. I think the consultant said it would be, changing out light bulbs kind of activities, something that would be really easy to do. And then the second level would be programs that could be offered. And so this would probably be things that ETO could help us put together, rebates, and those types of things that would lead to greater energy savings. And then the third level of the audit would be then how do we replace the rest of the plant usage with renewables or offsets? And at that point, it might be looking at the plant operations themselves to see if the plant is generating some methane that could be captured and used as RNG on site, or some of those kinds of things. So a little bit, that would be probably the most expensive but the kinds of things that we'll need to look at as we're looking at long-term, net zero kind of targets. So
Wow,
is
Lori,
that
thank you.
helpful?
That was really helpful. Thank you so much for going into such great detail, and that's great. And I hope we hear more about it later too. This sounds like it could be really amazing for these entities. And then, I'm just going to throw it out there. It would be really great if electrification could be considered too for any of those places where you can save. You can be more efficient, right? Reducing therms reduces emissions, which helps you comply with the climate protection plan.
Yeah, I think those audits will be a good place to start. They certainly won't be the end of the conversation. I think they'll be the beginning, the beginning of that conversation. And these will be very high level. And so there's, as I understand it, you can get into kind of an ASHRAE level audit, and this won't be that. It'll be much more high level, but it will be conversations with the plant specifically over the phone first, and then probably a walkthrough on-site visit as well. So looks like there's several hands. I don't know if these are for me or for Abby, but
I know Abe still had his question or a hand up, but he might have.
No, I don't.
Okay. Then JP, I think, is next. Yeah.
Hey guys, thanks for this. And just a quick question and it's going to be for Abby or Lori or anybody, but just in terms of the next IRP and what you guys are going to include, and kind of building on what Kara said about all things being on the table. Can you guys briefly talk about, or if you could comment on the extent to which the next IRP will do kind of a more of a look into the risk around growth and how that creates pressures and path dependencies that create more risks as you within the CPP, and get kind of relationship between an ever-growing system and compliance. It's not really here in your discussion of the different compliance instruments, but just that relationship between growth and that kind of pressures, no pun intended, that puts on your system around compliance and then more compliance instruments. Will that be discussed? Is that going to be how would it be framed up in the IRP? Because this is the CPP compliance, the growth does put pressure on you guys. Creates risk.
And this might be a question for Brian also, because we are modeling some of that.
Yeah, I can jump in. Yeah, so there's definitely risk around growth. Obviously, if we're growing our system and we have to reduce our emissions, we have to make sure we are able to still hit those emission targets by reducing, by providing a different fuel source such as RNG or hydrogen. And all growth comes in different shapes and sizes. Obviously, residential is a lot smaller. I think the main concern about growth is around those industrial customers. If you have an industrial customer come on and they're going to increase your load by quite a bit, the company definitely has to look at that and determine if that is a customer we can actually take on. So we're definitely looking at the risk of that, and we can probably add some language around the risk of growth in our current IRP. But one thing that we do show in our preliminary results is that we are still growing, and we do show that we can meet that growth based on the RNG and hydrogen projections that we see in our model. We also have a scenario that we are running on high growth, just in case growth is higher than we expected. And we'll show those results and how we can meet that load with the emission reductions that we have in front of us. I don't know if anyone else has anything to add to that.
Thanks, Brian.
Yeah. So Abe, did you have a question still? I see your hand is still up. Okay.
Oh, sorry.
No problem. Okay, so thanks, Abby. Thanks, Lori. Thanks everyone for all the good questions. That was a very, very good Q&A session right there. We always appreciate those questions.
Thanks.
I think what we'll do is we'll take a quick 10-minute break, and we'll come back at 10:30, and continue on with this presentation. Right. Thanks, everyone. All right, everybody, it is 10:30, so we're going to get going again. We are going to change up the order of the presentation a little bit. We want to make sure we get to Energy Trust before the lunch break. So I'm going to jump to ETO's presentation. So I'm going to kick it over to Monica real quick for introductions to DSM.
Good morning. Thank you, Brian. I appreciate the introduction. Let's go ahead and go to the next slide, please. So I'm Monica Kalasha. As I mentioned, I manage energy efficiency programs for Cascade Natural Gas. Right now, I'm partnering with the Energy Trust to present this information about our demand-side management overview. So we'll talk about that partnership. We'll also talk about Cascade's ongoing efforts, and you've kind of gotten a little bit of discussion already about what some of those ongoing efforts are, and then we'll kick it over to Kyle from the Energy Trust to talk about the forecasting for this IRP and what we're seeing as far as potential in the next, what I guess through 2050 is what we're looking for, but as far out as the models can actually provide for us currently. So we've got, as I mentioned, the Energy Trust will discuss just kind of who they are and what they do, go over the Energy Trust Resource Assessment Model overview and the methodology, and the savings projections overview, and of course the forecast results. Go ahead and go to the next slide, please. So as far as that partnership goes with the Energy Trust, Cascade's going to obviously continue to work very closely with the Energy Trust, looking at what those options are for our Oregon communities. Of course, as we've already talked about a couple of times, there's the climate protection program obligations that the Energy Trust actually will likely be able to help us with some of that. And then we have our local community greenhouse gas emissions targets as well. And actually, Brian mentioned some of that already when we're talking about working closely with Bend. And I'd put a note in the chat on some of the different individuals within the Bend area that we're talking to. You've got the Environmental Center and of course that climate task force. And then we'll talk about, RNG options and everything. So definitely continuing those efforts. Can we go to the next slide, please? So from Cascade's perspective, obviously, we also mentioned the transport customers, and Lori went really in depth on what our next steps are with that. Primarily, of course, we know that there's a lot of untapped potential to improve energy efficiency for those Cascade transport customers. And again, as Lori mentioned, between 30 and 40 of those customers currently well, it's actually a very large portion of our overall throughput, but it's limited number of actual customers. So first is we're going to look at the usage and data release considerations for those customers. That's kind of a little bit of sensitivity right now, mostly for the customers themselves, and then of course for private information. Those transport customers are not currently within the data release parameters that we have in place with Energy Trust, so we'll need to work on that, make sure we get all of those ticked and tied before we move forward, but that's definitely on our radar. And then of course we'll contract with the vendor that Lori was discussing to be able to offer those carbon compliance audits, to take that kind of customized approach, to working with those transport customers. And then after that, or actually in conjunction with that, as we're working on those other steps, we'll be working with Energy Trust and really trying to leverage their existing programs and looking at what the potential is once we've identified it. How are we going to help serve those customers, and what can Energy Trust's existing programs help us with as far as serving those industrial level customers. So in conversations with them right now on what that next step is going to be, likely in 2023. Next slide, please. And then from our community level efforts, we are going to be hiring a dedicated manager to focus on our Oregon territory for the energy efficiency program. So that would be essentially up here to me. Right now I'm focusing mostly on Washington, so this will be someone focusing on Oregon, really looking at that relationship with the Energy Trust so that we can make sure we're giving it all its due attention. There's additional budgeting requirements within Oregon as well, and so they'll be able to focus on that and those community engagement opportunities where we're talking about, what's next for Cascade and how do we help. I don't just want to say leverage, but how do we support a lot of what Energy Trust does with our customers? And of course, we mentioned Ben. I feel like I'm kind of echoing what we'd already talked about, but there's RNG outlook and the Ben climate priorities. When talking to that Ben staff, as I discussed, community data tracking, we've been doing that recently, and then open communication, and that manager that I mentioned that we're going to be hiring is also going to be focusing on how do we revise our low-income weatherization program for Oregon? There's lots of opportunities for improvement there, and we really want to get kind of down in the weeds with the agencies. How do we improve that process? How do we improve the program as a whole? What would actually work better for those agencies so that we can help serve those customers? There's been very little to no uptake in the last couple of years, and we see a lot of opportunity to switch that up. So we really want to have someone just focused on that. Really excited to see where that can go, and that'll be, addressed within the IRP. So I think that was the last slide for me. Can we go to the next one? Yep. Okay, so I'd like Kyle, if you'd be so kind, to take it from here on the Energy Trust efforts on our behalf. Thank you.
Yeah, absolutely. Thanks so much, Monica. So I'm Kyle Morrill. I'm a senior project manager here at Energy Trust of Oregon in the planning department. I worked on Cascade's resource assessment model this year, and so I'll be presenting our results, kind of where we're at for the modeling this year. I'll be presenting our base case results. I think we're going to do some sensitivity analyses for Cascade as well. But yeah, today just kind of focusing on the base case. So slide, please. Thank you. So I'll talk a little bit about Energy Trust, who we are, the work we're doing, jump into our resource assessment model, which for those of you following along in Washington is very analogous to the CPA, Conservation Potential Assessment methodology. I'll talk about how we deploy the RA model results into annual savings targets. Then we'll kind of dive into that actual forecast results a little bit. Slide. So Energy Trust, we're an independent nonprofit. We serve 1.8 million customers of PGE, Pacific Power, Northwest Natural, Cascade, and Avista in Oregon and Vancouver, Washington. We provide access to affordable energy, generating homegrown power, and building resilience in Oregon and Southwest Washington. Slide. So we've been in business since 2002. Served a bunch of sites. We've done a lot of work, a lot of information too, if you're curious. A lot of great information on our website about all the work that we've done. Really proud of all the work that we've done. Slide. So we work in all sectors, residential, existing, and new homes, manufactured homes. We work in commercial. We do existing buildings, new buildings, multifamily, strategic energy management programs. We also work in the industrial and agriculture sector. We're currently not serving transport sites, but as Monica spoke to, we're working, I guess, to work with those sites going forward. As Monica stated, maybe start working in 2023 to work with some of Cascade's transport sites. Slide. So we've been working with Cascade since 2006. We've served 20,500 households, 1,500 commercial sites, and 55 industrial sites over that time period. Slide. Slide. Thanks. So diving into what we're actually here to talk about today, the resource assessment model. Like I said, it's analogous to the CPA that is done for Washington. So the RA model, it's an input to the IRP, it informs the utility IRP planning process, spits out a 20-year energy efficiency forecast in multiple different iterations, I guess, of efficiency. And again, as an input to the IRP, it helps utilities plan for the future for both demand and supply side resources. Slide. So our RA model, it's a 20-year forecasting period. It's a bottom-up model. So we start from like basically stock, and we start from the measure level inputs at a unit basis, and that all scales up based on the inputs that I receive from Cascade and the other utilities. Our model is run in Analytica. This is a model that was built specifically for us by Navigant back in 2014. So as part of that kind of bottom-up approach from the stock-based unit, we're able to calculate technical potential, decrement that down to achievable potential, and then finally running all that through a cost effectiveness screen, we get the cost-effective achievable potential. There's a later slide. We'll kind of dive into the definitions of each of those slices a little bit later. But that all happens within our model, the Analytica model built by Navigant, and then we do an exogenous process where we take that 20-year bucket of cost-effective achievable potential savings, and we tailor that to a ramp rate where we actually get annual targets. And that tailoring process it kind of accounts for market conditions. It accounts for the current acquisition rate that we're on. We speak with Energy Trust program staff, internal staff on what our kind of like market knowledge expectations are, what our budgets are, what our forecasts are, to kind of tie this future looking forecast into current activity. Each time we run this model, so we're on the same cycle as the utilities IRPs. We provide these inputs every couple of years. So every time we rerun this model for given utility, we refresh all the inputs, we refresh our measure characterizations, we source new avoided costs, we update everything for each cycle to reflect the most up-to-date information. And we also make tweaks and improvements to the actual kind of guts of the modeling process every time as well. We're kind of always incrementally improving. Slide. Thanks. So speaking to those incremental improvements, we made a couple of modeling changes across all utilities that we work with to, and this, I guess, for our most recent Analytica model, so specifically to Cascade, changes since the 2020 IRP, we've tweaked how we account for lost opportunity and unconstrained potential. I have some slides on this a little bit later, but essentially, as stock and as conventional technologies expire through the modeling process, we have assumptions about how much of those technologies we actually acquire, and then based on the measure life, those will come up again later in the forecasting period. We've tweaked how we account for that. We've more aligned with Northwest Power Council methodology there. So we're actually kind of sweeping up in later rounds how we pick up this turnover potential. So we're able to capture a little bit more potential through that process. We've also aligned with current Northwest Power Council achievability assumptions. So that's, again, I have a slide about this later, but basically it's the jump from technical potential to achievable potential. There's an assumption of just how much of that in the marketplace at a base level efficiency can actually be acquired. Traditionally, that was a 85% estimate. It was based on a study performed in Hood River. And that was across all sectors, all measure categories. So the Power Council for the most recent power plan has updated their assumptions to be a little bit more measure specific at a high level. Shell type measures are assumed to be a little bit lower achievability rates, like down to about 60%. Whereas code changes, market transformation, et cetera, is assumed to be closer to 100% achievability. And then, like I was saying, for each round of IRP modeling, we have an internal engineering team here at Energy Trust that reviews our measures on a 3-year cycle. We incorporate all the most up-to-date measure assumptions in the RA model. We look at new emerging technologies in the marketplace, and any new measures that Energy Trust has adopted since the previous modeling. Slide. Thank you. So talking about those kind of 4 layers of potential I was talking about, with our model being this stock-based bottom-up model. So it's really helpful just to think about our model in terms of like homes and measures, I guess, or widgets, or whatever you want to call them. But so the first slice is, well, the highest level estimate that we come up with is the estimate of technical potential. That's essentially looking at all these homes and then all these inputs we have from like the RBSA, residential building stock assessment, or the commercial building stock assessment. We use this NIA data, and so basically we're able to estimate what's the technical potential that's out there. So that's basically like, you know, how many measures are available, minus ones that are just like not technically feasible or just not there. Our next slice is where we account for market barriers. That's what we call achievable potential. So like I was saying before, historically that's been an 85% assumption, but we've aligned that at a more granular level with the Power Council assumptions. So Shell being knocked down a little bit, code being knocked up, some other changes in there to more accurately reflect market barriers at the measure level. The next slice is where we apply the cost effectiveness thresholds, the total resource cost test, which I have a slide on a little bit later. But that basically tells us what portion of the potential that's out there that is achievable, what portion of that is actually cost effective, using Cascade specific avoided cost inputs. So all that is calculated within the RA model. That gives us this 20-year bucket of cost-effective potential available out in the market. And the final step that we apply is to shape that to current program activity. And that's where we account for program design, what our current market penetration rates are, what market conditions are looking like. And so we shape that 20-year potential to an annual acquisition over the time period with our ramp rates. Slide. Thank you. So here we're kind of detailing the inputs that go into our RA model. So it's kind of helpful to think about them in 2 sides. You have your measures, and then you have like as here I'm calling them the global inputs. But on the measure side, that's where we have the measure specific assumptions. So from the NIA building stock surveys, we're able to estimate the baseline and efficient equipment saturations. So that lets us know what percentage of homes already have quote unquote like baseline technologies versus efficient technologies. So we kind of get what the share of efficiency in the marketplace already is for year one. We have data about what each measure incrementally saves over baseline. We have data on what each measure incrementally costs over baseline. And then combined with this market data from the RBSAs, also bringing in suitability assumptions there. So how suitable a measure is for a given install. That's like all of our measure level unit kind of unit level assumptions, and then combining that with the stock side to know which measures are applicable to which stock. We source a lot of this from Cascade. We get their load forecast throughout the 20-year forecasting horizon. We also get a customer count or a building stock assessment because load isn't necessarily always fixed to stock. We get some demographic information about the stock, and then we source the utilities avoided cost information. Kind of combining those two things together is how we're able to classify the model. So then from all these inputs with the cost effectiveness screen, we're able to work through those kind of three buckets of efficiency we just talked about: technical to achievable to cost effectiveness, or to cost effective potential. Yeah, slide. Great. So yes, like I've been saying, it's a bottom-up model. Measures are characterized at a per unit basis. We characterize stock a little bit differently depending on the sector. This is also consistent with how the CPAs are done, and definitely how the Power Council in their ProCost tool classifies stock. So in the residential sector, it's numbers of homes served. We'll get that by single family, multifamily, and manufactured homes. On the commercial side, it's per square footage, and then by commercial type. So we'll have, X amount of square feet for office space, X amount of square feet for residential space, and then we assume different densities of measures per square foot, variably by type of business. For example, you would assume a higher density of cooking measures in a restaurant versus like an office space. You also assume higher space heating in an office space versus like some sort of warehouse or something. Then on the industrial side, the stock is just the load consumption, and then that's also by what we call the market segment or industrial type. Similar kind of analogous story there. You'd assume different measure saturations for like a wood products site versus like a food manufacturing, for example. So that's how we scale the model to each utility, and then we combine those utility specific inputs with the measure level inputs that we have. We kind of apply more universally. So little example down here at the bottom. If you have an efficient gas furnace, there's one furnace per home. If the furnace is at 50% of the baseline efficiency, you have 25,000 homes. You multiply all that together, and that gets you the savings potential. I think that would be the technical potential for gas furnaces scaled up in the model. Again, being this bottom-up stock-based approach, we start from the units, and then we're scaling up, tailored to Cascades territory in Oregon. Slide. Q. I'm falling behind a little bit. Maybe we should speed up. I think I kind of talked about this, but these are just kind of more information about the inputs. Like I was saying before, we kind of think about them in two buckets. You have your measure level inputs, and then your global inputs that relate to stock. We break up measures by sorry. We break up measures by the customer segments they're applicable to. We also break them up by their installation type, retrofits versus replace on burnouts versus new measures. We have information about their measure life. We have information about their savings, cost data, and then market data. And I think I've covered all the kind of the global input information. So slide, please. As I'm sure you can imagine, we have different measures that would compete against each other, or different measures would provide the same like a service within a home or whatever. So we have a methodology by which measures compete with each other, and they compete on a TRC basis. So over here on the left, this would be like the magnitude of savings we have from two measures. One being more cost effective than the other. A higher TRC score is a measure is more cost effective. So, if this would be this graph on the left is like the total availability in the marketplace, the more cost effective measure incrementally wins, basically. So the final savings potential as calculated is that graph on the right, where we the more cost-effective measure takes its market share, and then incrementally the less cost-effective measure captures the spillover, I guess. Slide.
Kyle, excuse me, there's a question from JP.
Oh.
Are you able to see that?
No, I can pull up chat though.
I can read it to you. It's, to what extent do increasing gas prices, higher avoided costs expand the stock of EE measures considered for screening in the forecast? Or does the model already have all measures included? Example, building shell measures.
Also reading along. Also,
Okay.
KJP. So yeah, the model already has all measures. Yeah, you too. So yeah, the model has all measures that we currently have classified, or also some emerging tech. All that it's already in the model. So the increasing gas prices, that helps on the kind of third decrement, where we do the cost effectiveness screening. So all measures contribute to the technical potential, the achievable, and then the avoided costs come in there with that third slice, where we calculate the amount of cost-effective potential. I see Spencer bounced on as well. Maybe he has something to add.
No, I was just jumping in to back you up. You said what I was going to say. Hey, everybody.
Great. Yeah, let me know if that doesn't answer your question, JP.
Yeah, sorry to interrupt your flow. Yeah, appreciate it. And just so you guys, just to be clear, you guys have, you think in your measure stock, you have all measures, including measures you don't currently offer in there to be assessed as what if scenarios as things move, get more expensive, more things become can enter into the technical achievable potential.
Yeah, I mean, we try to bring in emerging tech measures. So those are measures that we don't already offer. Those are things generally kind of on NEA's radar. So like the universe of measures that we are offering is like in there, and then anything we're not offering would be these emerging technologies that we bring in. I'm sure there's measures in the universe outside of those two buckets, but yeah, so it's a combination of our current measure characterizations, and then emerging tech.
Yeah, JP, if I may add to that, and hey, everybody, I'm Spencer Morrisfelder. I'm the planning manager, and Kyle and I work on the same team. We have done sensitivity analysis in the past to look at how different increases in gas avoided costs impact the overall cost-effective achievable gas resource. And what we've seen from those analyses is that you need to see pretty significant increases in gas avoided costs overall in order to significantly increase the amount of gas cost-effective potential. And so it's not really a one-to-one relationship, meaning that if avoided costs go up a unit, that we're seeing additional units of savings. It's much more of a stepwise function, and the avoided costs need to increase pretty significantly in order to see significant increases in that cost-effective achievable potential. So
Spencer,
hopefully that helps.
So Spencer, things like windows and wall insulation that aren't currently cost effective are in there, just in case that stepwise ever hits, right?
Yeah, so in the case of windows and insulation, in some of those instances, we have exceptions that have been granted by the OPUC, and we're already including that. Our measure development process is such so that we're exposing the measures that we're analyzing via that process to the most recent set of avoided costs. And so the measures that Kyle is talking about characterizations for, those are measures that have been screened and are either cost effective or have exceptions associated with them. And I think that typically covers the majority of the savings potential that we would be seeing. There may be some additional measures on the margins that were not cost effective, but I think as a rule, those would make up less of the technical achievable potential than some of the other categories that we're talking about. And again, those are measures that we actively have conversations with you all at the OPUC about. And in cases where it makes sense to be offering those measures under exceptions, we talk about that. And then you consider and grant as you deem appropriate. Did that answer your question, JP?
Yeah, thanks. And just for because I'm not totally up on it, I apologize. I don't want to. This is my last question. I won't hijack the rest of the meeting. Sorry, Kyle. The flow. How is the CPP changed your avoided cost calculations? Have you guys worked that out with CNG? How is that working?
Yeah, so every year, Energy Trust, the utilities, other stakeholders engage in a process that the OPUC leads. It's a docket, it's UM 1893, and via that docket, we update our avoided costs to incorporate the most recent assumptions associated with the current policy environment and how that policy environment impacts the avoided costs for Energy Trust funding utilities. We have seen pretty significant increases in avoided costs due to the inclusion of carbon values that are emerging from the CPP. And I think our most recent avoided costs that we're using for measure development have that value. And I'm not going to be able to cite this value precisely, but it's in the neighborhood of $80, $87, I think, per metric ton. If you start to include some of those other community values, I think that takes it north of $100 to closer to $107 per metric ton.
This question is actually for the folks at Cascade, but are you guys planning the IRP to discuss?
I'm sorry.
No. I just sorry to interrupt. I just want to make sure that you, just to follow up on that, like, so for Brian and team and Devin and everyone else, like, how are you guys going to? I think one of the things we'll want to see in the IRP is an articulation of how you guys plan to update avoided costs to better reflect the risk associated with CPP and properly value that. Spencer saying $87 a ton is well below what the price of a CCI is, which we think is the bare floor for an avoided ton of emissions.
Yeah. So
Spencer, that's not for you per se. That's just to put out there for the utility partners you guys are working with.
Yeah, this is Devin. I can kind of weigh in on what we're looking at for that. In terms of and I want to go back and double check what our inputs were, but I believe that for this modeling session, and I may be correct, I'm not sure when we locked it in, if the pricing of CCI was completely finalized at that point yet. So we continued to use the social cost of carbon as what we view as a valid analog for what we were expecting costs might ultimately end up as in that carbon compliance element of it. So that was, I want to say it starts around $87, $88 per decatherm, and it scales up pretty aggressively to the point where I think it ends up matching, if not exceeding, the forecasted cost of CCIs. But once again, I'll want to double check on that. But either way, one thing that we will do is vocalize in the actual IRP the decisions that we're making regarding that, why we're doing that. And the other thing we wanted to do was kind of similar to what Spencer referred to. The UM 1893, I feel like, is where a lot of these more holistic, qualitative decisions are made as to kind of what references and what tools we might want to use to value some of these resources. So we're excited for those conversations to begin rolling in. We filed our inputs for UM 1893 5 days ago on September 15th, along with, I believe, the rest of the other utilities. And I know conversations are going to be happening in that arena very soon. So I'm excited to see if others might have a different philosophy. The last thing I'll say about that is kind of to that point, JP, and we have some narrative, or we're going to have some narrative in the IRP about this, but one of the major sensitivity analyses that we're doing for this IRP is related to potentially the higher need for energy efficiency, and also just in general, what might be a different competing resource related to some of those elements of the avoided costs. And so in our high energy efficiency scenario, kind of similar to that CPP compliance, instead of using the traditional natural gas commodity cost as the commodity cost for compliance, instead we end up moving to using the price of, or kind of the marginal abatement cost of RNG or green hydrogen as a cost for that commodity element of it. And that kind of creates a higher avoided cost, and also allows us to test that sensitivity as to what the change might be when we do use that as the analog comparison. And I think we'll be able to write some interesting narrative once we have the results from, well, we do have the results from Energy Trust, but when we have time to kind of synthesize it and put it into the model, I think we'll be able to put some interesting narrative about how that impact plays. So I know that's a lot. I hope that answered your question.
No, that's great, Devin. Thanks. I want to be clear. You know, the design of UM 1893 is that the inputs, proxy costs, and a lot of things derive from the IRP, not independent from the IRP. So to the extent that this conversation that you're talking about, which I think is really, really fascinating, about the marginal abatement cost or whatever it is associated with the alternative gas being the proxy resource, that would be a great discussion. That would be a discussion we would anticipate you guys having in the IRP, not waiting for UM 1893, because 1893 is supposed to derive from analyses that come out of the IRPs to the extent possible.
Absolutely, yeah. And I think I do look at 1893 almost as an iterative process, where you're absolutely correct that when we make the filing, what we're using is either acknowledged IRP values or proposed other values that typically are, in the case of us with our filing, values that we're planning on using in an IRP. So for the actual quantitative filing element of it, 100% agree with you. It's all the stuff that's done in the IRP. And with these conversations, I think, at least in my experience, some of the past conversations around UM 1893 have opened up some really interesting dialogue channels related to kind of a qualitative perspective about some of these elements, right? Where we've all kind of sat down together and had those conversations about, should we be evaluating some of these elements differently? I know that's certainly led to, at least from Cascade's perspective, some of those conversations have led to philosophical changes or differences in distribution cost capturing. So I think there is that element, and that's kind of where it becomes this beautiful iterative process where the IRPs definitely do inform it and lead to those major cost projections. But I think there's also part of that process where we can learn and incorporate things from conversations with our utility friends and ETO. We can learn from that and ultimately incorporate a lot of that stuff into future 1893 filings and IRP processes.
Thanks, guys. Appreciate it.
Yeah, and I think I see Kathy has her hand up.
Yeah, I just wondered, Devin, are you taking into account the fact that the social cost of carbon may possibly be increasing by a significant amount? There's a study done by the Resources for the Future and a whole bunch of other organizations, including the EPA, which are proposing a value of $185. I'm not sure for what year.
Yeah, so that absolutely is something we're keeping an eye on. I know I've seen that there's a number of cutting edge studies. I've seen numbers as high as the mid 200s for the social cost of carbon. The tricky thing, we always like to emphasize this in the IRP, it is a point in time document to some extent. Eventually, we have to kind of let the rubber meet the road and say, this is when we're locking it in as of this vintage. And so at the time that we locked in the IRP, and we'll make sure we detail this in the IRP. But at the time that we locked it in, we were going with the most recent information we had related to the social cost of carbon, which was the 2007 study, with those values then scaled up to real 2021 dollars using the Bureau of Economic Analysis, CPI indicators, using their like chain link CPI table. So we scaled that up to real 2021 dollars. So we are using the most up-to-date data that we have at the time of filing it. We'll be absolutely monitoring what ends up happening with the social cost of carbon to see if that's something we may want to do in the next iteration of the IRP. We also may pivot from that entirely now that we're getting more concrete values in both Oregon and Washington as to what that carbon compliance analog might be, whether it is CCIs in Oregon or an auction marketplace or an offset marketplace in Washington. With those concrete values, we might be able to use those instead. But like everything, it's all point in time analysis, and we recognize that that can be problematic. But we're going to do the best we can with the information we have, and we will document and discuss and justify all of the decisions we make in the IRP.
Okay, thank you.
Yeah.
Awesome. Thanks, everybody. I'll also try to kind of speed up a little bit. So slide, please. So this kind of also speaks to or answers JP's question a little bit, but so we, I guess like we were talking about before, on the measure characterization side, we have all the measures that Energy Trust is offering, including the ones under cost effectiveness exception, combined with any emerging technologies we see in the next couple of years. And we apply that, we apply a cost effectiveness screen to all those measures based on the avoided cost inputs we receive from Cascade, and then the measure benefits as defined by our measure characterizations. So if that ratio is above 1, a measure is cost effective, and it gets included in that third decrement. So what is the TRC? The TRC is a benefit cost test, where the costs are the annual measure savings times the net present value of the avoided costs per therm. Sorry, these are the benefits. The benefits of the avoided costs, where you have the annual measure savings multiplied by the net present value of the avoided cost per therm. We include any quantifiable non-energy benefits in that benefit numerator as well, being like water savings from measures that would use less water for water heating, and then the denominator being the total measure costs. It's the full cost for retrofit measure, and then the incremental cost over baseline if we're looking at a replacement measure type. Slide. Thank you. So like Spencer was talking about, we do have some measures under cost effectiveness exception from the OPUC. We also, since we run a statewide program, we calculate a blended avoided cost where we weight, it's basically a weighted average avoided cost where we have the inputs for our three gas utilities we work with. You basically weight their inputs based on the size of their relative budgets. But we do run the resource assessment model with cascade specific avoided costs. So there could be instances where that delta in avoided costs screens out some measures as not cost effective within the model that are cost effective under the blended avoided costs we actually implement in the marketplace. So I'll look through the model and see if anything's being screened out because of that reason, and then I will cost effectiveness override all the measures that are under OPUC exception under UM 551 criteria. So I think the next slide details, so slide please. The next slide shows, okay, maybe it doesn't, but what we're offering under cost effectiveness override right now, or under exception from the OPUC, some insulation measures, some clothes washer measures, and I think a gas manufactured home replacement measure. I can dig up the full list if that's helpful for anybody, but that's what we have off the top of my mind. So yeah, I think we detailed kind of all the inputs. We're going to see a bunch of slides that show the results. So, you know, the outputs that we can calculate from our model are those types of potential we talked about. We get levelized costs, cost and benefits for the TRC tests, and we can get supply curves. Slide. Great. So I think here detail a little bit how we deploy the potential. So slide. Like I've talked about before, you know, the RA model calculates this kind of 20-year bucket of potential out in the marketplace, and then we run an exogenous process to tailor that potential to current energy trust activity and market conditions. We do that via a process or a methodology we're kind of calling ramp rates. So when you multiply a ramp rate by you know, the total potential out there for in a given year, you know, you get some share of that potential that you're acquiring, and then that share is an estimate of how much of the available potential will come off Cascade system in each year. Our ramp rates are based on Northwest Power Council methods, and then we calibrate them to be specific to Energy Trust's current activity, what our budgets are expected to be, you know, even to the extent of what certain measures that, you know, utilities are more interested in. We can tailor all that through the ramp rate process, which really makes the, you know, it makes this modeling exercise specific to Cascade. Slide. So there's at a high level, there's kind of two types of ramp rates we will apply to the total cost-effective achievable potential. Retrofit measures assume that 100% of the potential gets achieved over the time period via a bell curve. So we will ramp up our penetration throughout the time period, and then that gets tailed off until we acquire all the measures, assuming that, you know, each kind of measure after a certain point is marginally more difficult to get than the one prior. On the other side, we have lost opportunity and new measures where every year we're increasing our market penetration until we eventually achieve 100% market penetration, and then you know, every new measure that comes up we'll be able to achieve. So this process is, you know, pretty consistent with the Northwest Power Council deployment methodology. There's also consistent with Northwest Power Council is that there are measures that are difficult to achieve where we don't ramp up to 100% over the time period. So be emerging technologies, we allow them to come in at a pretty slow rate and then acquire market share consistent with what we've seen in the past. And then also there's certain hard to reach measures, which are generally shell measures, so insulation, windows, etc., that are also hard to acquire, and they may not ramp to 100% over the time period. Slide. And it just shows each of those curves. So the yellow curve being the bell curve that I talked about before, the retrofits. The scale of the retrofit acquisition is on the left. And if you sum up each column, if you ran an integral over this curve, it would equal 100%. Then the lost opportunity scale is on the right, where we're slowly acquiring market share over the 20-year period. And in year 20, we're capturing all turnover in a given year. Slide. So our calibration process, the years 1 through 2. So in this IRP, it'd be 2023 and 2024. That pretty much comes directly from our program budgets. We will tailor the near-term acquisition with what our program budgets are. In years 3 through 5, we work with planning. We work with program managers to kind of create a forecast what their expectation is. It's not run through our formal budget process, but we check in with programs and we kind of combine our own forecasting methods to get kind of like an in the middle tailoring process. And then in the out years, we just run the formulas, we run like the ramp rate algorithm, and those follow the Northwest Power Council methodologies. So it's kind of tailored through the period where the near term we're taking our actual budgets, and then it's slowly just let the ramp rates come over, take over in the out years. Slide. Yeah, so what this allows us to do is to tailor the results to Cascade and to our current program activity within Cascade territory. I think I'm gonna try to speed up a little bit. So slide. Thank you. So start talking about results. This graph shows the cumulative savings by type and year. So the top 3 lines is the technical, and then the decrement down to what is achievable. So generally 85% of technical is achievable, with lower for shell, higher for code. The next line, that kind of green, is what is lost. The difference between those 2 lines is what is not cost effective. And then going all the way down to the gold line that's those deployed IRP projected savings. The thing that jumps out to me is the kind of the relative larger drop from what's cost effective achievable to the IRP projected savings. Decent amount of that in this modeling run is residential emerging tech measures. A lot of gas-fired heat pump water heater savings that come in a little bit later in the time period and ramp up over time. So that's showing a lot of that. That's reflective of a lot of that difference between what's cost effective and what we're deploying. Slide. That same graph, but broken out by sector and not being cumulative. So these are our deployed IRP forecasted savings. See, residential is growing over time, reflective that there's a lot of potential out there. We're a little bit earlier in our acquisition period, whereas commercial and industrial are tailoring off. So we're kind of further along in that bell curve for the retrofit measures. We also look at unclaimed market savings. So that's NEA's commercial activity with the way that we kind of divvy up NEA commercial savings within our territory. And then in years, I guess 3 through 20, we add a large project adder, because generally through our industrial program, sometimes commercial, we get large projects at irregular intervals. They're kind of hard to account for in our modeling, so we'll have visibility if any are coming up in the near term. So that's why there's not that large project adder in years 1 and 2. And then that out year adder is basically, it's like we're just calculating the median of the large projects that we've done and then adding a little bit year over year. So generally the way these large projects work is if, let's say we get one, let's say we get one every 4 years, it's 1 million therms. The large project adder would be basically 250,000 therms per year to smooth out those projects that we don't necessarily anticipate, but we know will on average come along throughout the 20-year period. Slide. Thank you. This details the savings by sector and type. So similar information to that previous graph. You can see residential makes up a larger share than commercial industrial. Like I was saying before, there's this drop off between what's cost effective, achievable, and the IRP projected savings, a larger percentage drop off for residential than the other sectors. And that's those gas fired heat pump water heaters combined with a higher share of hard to reach measures, being the shell, insulation, windows type measures. Combining those two factors, also the fact that we're earlier in the acquisition period for residential, like capturing more water heat savings later in the period, that all contributes to a larger decrement between what's cost effective and what we're actually deploying for the IRP. Slide. Thank you. Shows that same information, but with actual values of therms and then cumulatively over the 20-year period. So you can kind of see the magnitude of decrement between what's technical, what is achievable, what's cost effective, and what is being deployed in the IRP. This is the cumulative modeling results. So any exogenous savings, like the large project adder, the unclaimed market savings being the NIA commercial savings, are not included in this bottom line number. So this is just the share of what's cost effective coming out of the model being deployed here. See, there's a hand up. Monica?
Yeah, I just had sorry, Kyle, I just had a quick question.
Yeah.
You mentioned those measures that have waivers for cost effectiveness. So does the potential for those not fall within any of these specific buckets?
They do. They're in each bucket. So it's yeah. They would be screened out in the cost effective achievable potential. So let's say I hadn't applied cost effectiveness override, they would live in the achievable potential row, and then they would get screened out. So they wouldn't be in this cost effective achievable row. But because I'm overriding their that screen, they get included in what's cost effective.
Okay, thank you very much. I appreciate it.
Yeah, absolutely. Slide. So here I'm able to show within our model we have information on end use. So this shows both what's in total cost effective and then what's being deployed in the IRP for the cumulative 20-year results. You see that the largest deployed contributor is heating, followed by water heating, and then kind of to what I've been alluding to with the gas-fired heat pump water heater. It's always a tongue twister. Because we have that emerging tech coming online for the water heating emerging tech, there's a large decrement between what's cost effective and what's deployed because of how we're applying that ramp rate to that emerging tech measure. Slide. Hey, this is what I was looking for. So these are our current measures under OPUC exception. So all of those are not being screened out between between what's achievable and cost effective. So these are all included in our final IRP savings values. a lot of residential insulation measures, clothes washers, commercial insulation, and then gas heated new manufactured homes. We all have under OPUC exception for right now. Slide. So just to get a sense of the magnitude of what the measures under exception are contributing, for the final deployed IRP savings, it's 3.7% of the total potential. A little bit lower share of what is in total cost effective. So 500,000 therms is basically coming in through our measures under exception. Slide. Thanks so much. We're also able to estimate peak impacts by major load shape. So you have our peak factors and our load shapes, and then you multiply that through by the magnitude of savings, and we get an estimate of the peak impacts. So, you know, as you can see here, residential heating has the largest peak savings value for what's being deployed, followed by commercial heating. Yeah, slide. Thank you. So yeah, we're able to calculate supply curves. So as this is showing cumulative potential and then the levelized cost, the dollar per therm value. Somewhere along this curve to the right would be our cost effectiveness cutoff. So there's, you know, kind of a big stepwise jump at, you know, $1.20 per therm, and then, you know, they start getting more expensive. So we're able to acquire everything under this curve that is cost effective. Slide. This more details what I was just talking about. The x-axis, the horizontal axis here is the total resource cost test. So looking over, you know, sliding along the x-axis until you get to 1, that being our cost effectiveness threshold, you know, we're right up to around the 19 million therms that is coming out as cost effective, achievable for the Cascade studies. We're able to acquire all those savings under the curve, and then that tail is what's left over and not cost effective. Slide. Thank you. Comparing this graph here is comparing the 3 of our most recent IRP runs for Cascade to what our program actuals have been. So the 2023 IRP is the blue projection. We're projected to get more savings than we have in the past. Also a little bit earlier in the time period, and then it tapers out. You can see we've been pretty consistent with IRPs over time. We've been more aggressive in the near term, I think partially in response to legislation, acquiring more savings earlier in the time period. And that's also consistent with the kind of ramp up in actuals minus some pandemic effects here in the near term. And kind of ramping back up to normal activity, also as eventually market conditions, supply chain, et cetera, inflation kind of settle out market expectations a little bit. Slide. Here we're comparing the past, our targets versus what we have actually achieved. Generally hit our targets. A little bit of difficulty here in the near term with some pandemic related impacts, et cetera. You can also see that, you know, residential has been pretty consistently growing over time. Commercial and industrial a little bit more lumpy. Yeah, impacting kind of our total performance. Slide. Thank you. This graph is showing the projected savings as a percentage of Cascade's load. So really we're bouncing along at about a 0.67% annual savings of Cascade's annual load. So cumulatively over the time period, we'll save about 11% of Cascade's load in 20 years, bouncing along at about a 0.7% per year. Slide. Yeah, that's what I've got. Thank you all for your time. Happy to take any questions.
I'm not seeing any questions. Going once, going
Great.
twice. All right. Thank you, Kyle, for that presentation, and thank you both, you and Spencer, for all the work you guys have done in Energy Trust. And we appreciate the coordination with you guys. So thank you.
Yeah, absolutely. Thank you. And yeah, my information's on the slide. Anyone feel free to reach out if any questions come along later.
Yeah. Yeah, definitely. And if you have any, you can send those questions to us as well, and we can get in touch with Energy Trust. So either way works. All right, thank you.
Great. Thanks, Brian.
Yep. All right, so we have about 25 minutes to lunch. We probably have about 45 minutes to an hour left of material. So I'm gonna open it up. I wouldn't be opposed to doing a quick 5-minute break and then finishing out. If people want to break for lunch now and come back at 12:30, we can do that as well. So I don't know if there is a preference one way or the other.
I vote for keep going. This is Kathy.
Okay. Okay. Unless I hear otherwise, we'll take a quick 5-minute break and then we'll finish it out. Okay, I see Kim has agreed to that. Okay. I'm not hearing anyone opposed to it. So let's take a quick 5-minute break. We'll come back at 11:40 and then we'll finish off this presentation. Thanks, everyone. All right, it is 11:40, so we'll get going on this the Tag 4 presentation. So we talked a lot about RNG and it being a way to reduce emissions on our system. So I'm going to give a little bit of a background on what RNG is. For those who are not familiar with it, if anyone watches this recording and isn't familiar with RNG, here's a little bit of information. So RNG, it stands for renewable natural gas, and it's pipeline quality natural gas produced from various biomass sources through biochemical processes such as anaerobic digestion or gasification. I've also put a link here to the U.S. Department of Energy. There's a lot of good information out there about renewable natural gas. If anyone is interested in doing further digging on RNG. So some examples of, yeah, Kathy, do you have a question?
The previous slide?
Yeah.
Well, okay, maybe this one will do too. I'm concerned about what's in that cleanup because it's my understanding there can sometimes be significant emissions as part of that cleanup process. Is that correct?
Yeah, so from what I understand, there is some emissions as part of the cleanup, and we do tie some very small emissions to RNG in our modeling. So when the model decides to pick up RNG as the resource, there is a very small emission factor that is tied to it. I don't know what the emission factor is off the top of my head, but yes, there is some small emissions factor tied to RNG.
Yeah, I suspect that there may be a lot more associated with some of the dirtier fuels to start with.
Yeah, yeah, and I'm not
you guys may not you guys may not be quite as susceptible to this as some of the others.
Right. Yeah.
Hey, Brian, this is Abby.
Yeah.
I'm familiar with how this is done at landfills, and I think it applies to some of the other types of RNG, but you're required to put pollution control devices on, whether it, when you're cleaning up the gas, you could be creating like a nitrogen stream, nitrogen NOx, or even some other constituents that come out there. But there are devices that you'd have to install to clean up the and capture those pollutant emissions, so, or treat them. So there are those requirements, and that's done.
All right, thanks, Abby. And thanks, Kathy, for the question. So here's a few examples of renewable natural gas. So there's biogas from landfills where they collect waste from residential, industrial, commercial entities. Digestion process takes place in the ground rather than a digester. There's also biogas from livestock operations, so animal manure delivers to anaerobic digester. There's biogas from wastewater treatment, where we it's produced during digestion of solids that are removed during the wastewater treatment process. And there's also other sources, such as organic waste from food manufacturers and wholesalers, supermarkets, restaurants, hospitals, and much more. If you want to go out to the U.S. Department of Energy and check that out. And then this graph is from the U.S. Department of Energy. They have these graphs for all these other types, but this one is anaerobic digestion products. So you can see it takes the gas, does a moisture removal. It can flare it, or it can go through sulfur removal, goes into a compressor, then you can turn it into biogas, or you can remove the CO2 and then turn it into RNG. Sorry, I heard some noise. I don't know if someone had. Is there someone that has a question or? Okay, I will keep going. So some benefits of fuel diversity. So the use of RNG increases and diversifies domestic energy production. It can be used as a baseload fuel source for with high availability rates. It leverages existing infrastructure, so we can use the natural gas pipelines that we currently have out there for RNG, as well as heavy duty vehicles. And biogas feedstocks for RNG are generated continuously from a variety of sources. There's also economic benefits. It can benefit the local economy through the construction of RNG processing and fueling stations. There's also national, state, and local incentives that may be available depending on the end use, such as credits for production of RNG used for vehicle fuel. And then, of course, just that local economy, going back to that, if there's a food manufacturer, for example, if they dive into this RNG, maybe that can keep food pricing down. So there's definitely some economic benefits to renewable natural gas. And of course, there's local air quality benefits. So replacing traditional diesel or gasoline with RNG can significantly reduce emissions of nitrogen oxides and particulate matters. So this results in local air quality benefits. RNG is comprised primarily of methane compared to natural gas. RNG contains 0 to very low levels of constituents such as ethane, propane, butane, pentane, or other traces of hydrocarbons. And then obviously greenhouse gas emission reduction. So RNG projects capture and recover methane produced at a landfill or anaerobic digestion facility. It has a global warming potential of more than 25 times greater. Sorry, this is methane. Methane has a global warming potential more than 25 times greater than CO2 in a relatively short, so 12-year atmospheric life. So reducing these emissions can achieve near-term beneficial impacts in mitigating global climate change. And then I put 2 slides in on benefits. I didn't really want to put it in a slide about like the negative part of RNG, because I think RNG can be very beneficial to the energy system. But one of the downfalls of RNG is it is pretty pricey. The prices are up in the higher $10, lower $20 range, sometimes in the $30 range. So when you compare that to the traditional natural gas, currently that's pretty high as well, up in the upper $9-10 range. But generally, a few years ago, it was down in the $3 range. So just looking at the cost of that is one of the concerns that we have to take into consideration when we're modeling this RNG. And then I just have a brief, I think it's a 2-minute video to share on RNG.
Quebec's energy future depends on an increase in the production and use of renewable energy, like solar, wind, and hydroelectric energy, as well as renewable natural gas. Renewable because it is generated from residual organic matter, such as food and agricultural residues. Think table scraps, grass clippings, cow dung. These are all types of natural organic matter that are in endless supply and quickly renewed. And thanks to processes like biomethanation, these residues are transformed into renewable natural gas. By this process, the residual organic matter ferments in an oxygen-free medium called biodigester. Its fermentation produces gases which, purified, become renewable natural gas. This energy can then be used for cooking, heating, and transportation. Natural gas is a great way for a city, a region, a community, or business to value its residual organic matter, and to produce locally an energy that is 100% from a renewable source. With renewable natural gas, imagine energy differently.
I see we have a question in the chat, and how much processing is required to get RNG from a landfill or sewage system to pipeline quality? What impact does the sulfur processing have locally where it's completed? And I'm going to see if Kent, would you be able to answer this question? Or is this something we should try and get back to them on?
Sorry, Brian, I didn't hear the whole question. Could
Yeah. So how much processing is required to get RNG from a landfill or sewage system to pipeline quality? That's the first question.
It's kind of similar based on the projects that we are working on in Washington and Oregon now. The difference in processing from landfill or wastewater treatment facilities that we've been looking at are not vastly greater. The landfills tend to use pressure swing absorption for a scrubber means, and they usually have 2 trains of that, meaning there's basically 2 passes of the scrubbers, and the second ones are mostly to clean out the nitrogen and oxygen as low as we need it, because it tends to be higher on landfills because there's more oxygen air penetration in those processes. But and also you have siloxanes sometimes in those areas, as well as wastewater treatment plants, which we have to get out of the pipeline. So there's some additional work for that, but it's not something that releases emissions in terms of cleaning it up. That's a chemical process to the pressure swing absorption units. In terms of most of the other units that we look at, they're generally using membrane-based systems, which are also very contained. It's not a big difference in terms of what I've seen. I don't get inside. I do work directly on scrubber development on some of the early projects, but most of those units have been on the membrane side. But I'm not sure if I'm answering this question what you're getting at, but we don't see big differences thus far in terms of what we're doing for cleanup. Landfills tend to take a little more work, but and the siloxane is the big difference with the wastewater treatment facilities versus the others. But literally using the same scrubbers, let's say, I've got an example of one where we're working on a food waste manufacturer, a food manufacturer who we're dealing with their food waste for an RNG plant versus another wastewater treatment site for industrial wastewater treatment. And they're using the same type of scrubber on those 2 units. They're both facilities are looking at a membrane scrubber from the same manufacturer to do the process. So there's really not much modification in those 2. I hope that helps. If you want to get probably deeper, it might be good to talk to a scrubber manufacturer to get into that discussion.
Yeah, Heidi, did you want to expand on that? Heidi, if you're talking, you are on mute. Okay, I see Heidi's hand is up. She did put a clarifying question or clarifying statement in the chat saying what kind of energy input is what she's asking about.
Are we talking about energy input into the scrubbing process?
Yeah, maybe we'll come back to that.
Yeah, I can actually address that with kind of a specific percent when I get into my discussion. I can.
Okay. Yeah, we'll come back to that. All right, thanks, Kent. So now we'll jump into the principles of RNG cost effectiveness evaluation, and I'll pass it over to Devin.
Thanks, Brian. So I just got a couple of slides going over how do we ultimately look at the cost effectiveness for renewable natural gas? What are some of the inputs or some of the toggles that we can do into that evaluation? So Brian already kind of alluded to this. There is a little bit of an issue on the surface that RNG appears to not be cost effective when it's compared to traditional natural gas. I looked at prices at Sumisk for the upcoming winter, for instance, and even with the spikes that we have as of yesterday, Sumisk for the upcoming winter was trading around $9. While that's high, it's still relatively low if you compare it in a vacuum to the 14 to 26 and even excess of $30 per decatherm that we might be seeing for some of these renewable natural gas projects. However, there are a couple of factors that can end up leveling the playing field on this. There is a potential hedge value of RNG. For those who paid attention during our last tag meeting, I did a little bit of a conversation about the hedge value of energy efficiency. It's a similar concept when it comes to renewable natural gas. The fact that if we engage in a long-term contract for renewable natural gas at a fixed price, that's a hedge in the same way that a fixed price physical would be a hedge. And so there can be some value to that certainty, or the same way that energy efficiency is a hedge. There is some value that we identified in our last meeting, and that can be applied to the RNG certainty as well. Now, that's not to say that RNG is fully certain. We've also talked about in the past that there is some uncertainty potentially around how much RNG that you can actually get. But in terms of what you'd actually be paying for, that amount would be fixed or hedged. There's also that value of the environmental attributes. We were talking about that quite a bit during some of our prior meetings as well. And the conversation that JP kind of started talked a little bit about that as well, is there's value to not being able to have to buy, say, a CCI or participate for one auction credit in a Washington auction marketplace. RNG allows you to have that, and it reduces our emissions, both of which are very important. But that kind of quantitative valuation really occurs in what is the marginal cost that is offset by having that RNG. What don't you need to buy? Whether it's a CCI, whether it's a more expensive RNG project, whether it's hydrogen, there's something that can be offset, and so there's value to that. And then finally, there's also cost savings that can be related to building versus buying. We have two different models that can address those questions if we're going to be looking at building a project versus buying a project. Building typically at this point does seem to be somewhat more cost effective is what we're seeing. We're still heavily kind of figuring out what the costs are going to end up being on the Deschutes landfill project that's been talked about quite a bit. But generally speaking, the dollar per decatherm overall that we're seeing on that building side of it tends to be a bit cheaper than just going out to a marketplace and buying the attributes or buying the gas, especially if you have to go through, for instance, go through a third party who may end up having some kind of middleman fee or brokerage fee as well. Kara, I see as a question, are these costs for the RTC plus energy or just for the RTC? I think both. I think it depends. That's something that our models can account for, is are we looking at just the thermal credit? Or are we looking at the molecules as well, or are we just looking at the thermal credit? I think these questions come up in all of these. The hedge value, I guess maybe not so much actually, because we would still need to go out, if we're just buying the RTCs, we would still need to go out and buy traditional natural gas, and maybe there's less value for the hedge on that. But the value of the attributes absolutely does come into play here. And then the building versus buying equation. We look at the fact that if we're building, we almost certainly will have the molecules. I guess we could build something off system, but everything that I've seen has been on system building projects that have been proposed. So yeah, we can account for that in our models. How much ownership we may have of it, how many actual molecules we might be getting from it, or if we're just looking at RTCs. We absolutely do evaluate that when we're doing those cost effectiveness evaluations. And I hope that answers your question, Kara. So it's a critical resource for us in the projected compliance resource stack, but it must be acquired prudently. We've seen a number of projects, as Brian has talked about. We're not just going out and acquiring every single project, whether it just be RTCs or an actual molecule of RNG. Something at $30 per decatherm, for instance, could have some prudency issues. that we may not want to ultimately engage in unless it truly was a resource of last resort potentially. When things are not deemed cost effective, they still could be a desired resource under certain regulatory exceptions. Once again, that's not saying that we're going to be going out and buying $35 per decatherm RNG, but we do need to look at SB 98. I'm just reading Kara's comment to please make it clear what cost you're using and what they reflect. Absolutely, yeah. So when we are talking about just RTCs, we will kind of refer to it as such. When we're talking about that bundled product, including the molecules, we absolutely will. And when we're showing any cost information that we're projecting, we'll make sure to clarify it. That's a great point, though, and thank you for that feedback. Absolutely. But yeah, so getting to that point, it may be desired if it makes sense. There is some exception, although as a smaller utility, SB 98 is a slight bit more nebulous for us. We don't have a hard, for instance, 5% cap on impact to revenue requirement. That is somewhat more negotiable depending on what our need is. And as we're going to continue to explore that SB 98 process, that may be an avenue that we would end up going under certain conditions. Kim, I think I see that you have your hand up.
Thanks, Devin. And this is really helpful. I really appreciate sort of how you're articulating your thought process around the cost-effective RNG and SB 98, and look forward to more conversations on that. One thing I'm wondering about is, while I think I heard you say that the buy or the build options appear to be more cost-effective than the buy options. How are you thinking about the differences in risk of those different types of projects? And is that something that, you're going to be elaborating on or providing more insight on in the IRP itself?
So that's a fantastic question. And I think it's one, unfortunately, we're so new to the game on this that there might be some knowledge gaps for us when it comes to risk. And I think that's information that we will present, frankly, in the actual narrative, because on the surface, if everything comes out as cost projections on a build project as expected, then it would look great. But we're already seeing, to be frank about it, that projections have changed on an upward movement based on inflation and as the projects take time to ultimately develop. And so that is a huge risk. I think, and a bit of a stretch goal for us for a future IRP, once we have more data, we're especially here at the resource planning team, we're always looking for data. Once we have more data, we'll be able to do some kind of quantitative analysis about that. If we can see, for instance, what the variance might be for different factors of the build project, whether it's materials costs, whether it's staffing costs or labor costs, we can do stochastic analysis if we have an idea on what some of those variances are on those to create those risk bands in the same way that we would do it for every other process. We just don't have that internal data yet. So I think what I would expect we would end up doing for this IRP cycle is presenting that as a challenge, but also something that we are absolutely monitoring and something that as we get more data, I think we will be able to make some of those risk analysis decisions related to the build versus buy decisions.
Great, that's helpful. And for what it's worth, I know that there's more to sort of explore in terms of how that risk then is ultimately borne by investors versus customers, and the ownership structures that get crafted as you envision some of those build projects. So plenty of room for more conversation there, but that's really helpful.
Absolutely, yeah, and I think that will be a vital part of the RNG chapter, is outlining and explaining that we are cognizant of those risks, helping stakeholders see what some of those risks are for those who might not be aware. Once again, the fact that building costs can go up, the fact that labor costs can go up, that might not be something that people, certainly when we were first looking at it, I wasn't thinking about it. And as I've become more knowledgeable about it, I think it's important to recognize that that is a risk. And then, like I said, hopefully once we get data about it, the one thing that, we love working with those kind of numbers and stuff. I love doing that value at risk analysis like we do on the natural gas pricing side of things. We could absolutely do a similar process where we do a Monte Carlo simulation looking at what some of the variance might be under those costs and project out, let's say with 99% certainty, cost wouldn't exceed X. And then how does that compare, say, to a purchase decision? We could do a risk adjusted analysis like we do for some of our other processes to kind of come up with some of those metrics. I think there's a lot we can and want to do with that.
And I'm sorry, one last question in this space is, do you picture doing RFPs for the build projects or where there's a transfer of ownership, or I don't know, how are you envisioning finding these projects and acquiring them?
I will absolutely throw that to Kent because I think that's going to be more in his wheelhouse.
I'm sorry, could you repeat the question? I didn't hear it all.
Sure, it was just whether you were envisioning using RFPs to identify and acquire some of these projects.
That's not the way we've been approaching it right now, primarily because I'm one person kind of doing most of our development across the territory. We are looking in particular at places where there are digesters in place that are being flared or just not utilized, and trying to take those opportunities as the more low-hanging fruit, because there's a lot of investment already in place that's not being utilized. And that can be, if it's in a good position in relationship to our system and a place where we can onboard that gas successfully, then those are the kinds of places that we are targeting currently. And we do respond to RFPs from developers too. If there's I'll talk more about that in my presentation, but we are not putting out RFPs for those kinds of projects yet. I wouldn't rule it out in the future as it becomes more difficult to find projects that we can readily develop.
Great, thanks.
Okay, and so there's also a question in chat from Kathy asking, what does SB 98 require us to do that is not required by the CPP? Abby, do you want to go ahead and address that? Because I see that you've turned your camera on.
Actually, I was going to add something else to the last response. And I don't know if Chris Robbins is still on, but so there's two different areas we have at this time kind of working on the RNG procurement piece. And so in our gas supply group, we do look at potential RFPs for RNG and attributes in that context. So we are doing that. And then when we're doing that, I think those projects are getting bid to us in that way. So I'll just leave it at that. And then we continue to evolve, as Devin was saying. So yeah.
Yeah, and
Let
me add one more thing to that too, because that's a really good point by Abby. The RFPs that Chris is looking at are generally off-system RNG sites. What I was talking about as far as direct development, we don't use RFPs. It's for on-system RNG projects that are directly connected to our distribution or high-pressure systems. Thanks.
Okay, so getting back to Kathy's question, what does SB 98 require you to do that's not required by the CPP? I will invite Lori and or Mike to interrupt me if I speak incorrectly on this, because I am not as knowledgeable on some of the regulatory things as they are. But it's my understanding that we don't actually have any requirements in SB 98, and I might, if I'm incorrect on that, somebody please correct me, but that's more of as a small utility, it's more of an optional avenue for us to engage in because we are a smaller utility. The goals are going to end up ultimately interlocking hand in hand. It's both of them, I believe, have the same ultimate objective of reducing our emissions. I think it's just different vehicles that we could use to ultimately go through one versus another, right? I think it's just maybe another opportunity even to have a different regulatory focus on it. If we, let's say, had a project that were to increase revenue requirements somewhat significantly without, in a vacuum, that could be potentially problematic, but allowing it to be vetted fully through SB 98 might be a beneficial route to go. I see Mike's turned his camera on, so before I put my foot in my mouth any further, I'm going to let him go ahead and take it.
Yeah, I think kind of a simplistic approach to the Senate Bill 98 is, well, we're talking about the carbon compliance side of things, and we get the targets that we are required to meet from a carbon compliance standpoint. And RNG is a component to achieve that. So if you're looking then at RNG, Senate Bill 98 steps in and kind of goes, okay, if you're looking at RNG, these are the things you need to do to bring that RNG online. Yes, it's kind of from a small utility standpoint under Senate Bill 98, we aren't required to do anything unless we bring RNG onto our system. And then we have certain requirements under Senate Bill 98 that we need to do to be able to bring those onto our, not so much onto our system, but to seek rate recovery of those projects.
Yeah, and I think I'll clarify also, when I say cost effective in this environment, so in the context of this slide, it's not necessarily cost effective when compared to the climate protection program. It's more of a pure one-for-one cost effectiveness. So obviously the climate protection program now is going to be a significant part of that RNG cost effectiveness. But when, we may have been looking at it in the past as just value of environmental attributes versus value of the molecules when compared to, say, just going out and buying gas plus some other kind of auction requirement. That was kind of the main evaluation we were looking at when we did this initial cost effectiveness evaluation metric. And under that umbrella, that's where we kind of looked at SB 98 as a potential alternative to just this more insulated cost effectiveness evaluation. But I think kind of like Mike said, SB 98 is going to be the tool that's ultimately going to be used if we do end up having to get RNG on the system because of the CPP compliance. And that's something that we're going to, have to be able to show why we may be engaging in certain projects. I hope that answered the question. Once again, SB 98 is something that I don't spend as much time on, so I apologize if my expertise is.
And I apologize that I'm not that familiar with its specifics. I was familiar mostly with its percentages, and since both CPP and that, but what you're saying is that there's some actually different qualifications for renewable natural gas in the two programs. So that's interesting.
Yeah, so SB 98
not worth discussing further at this meeting, so we can get to lunch.
Sure. Yeah, that's actually a great point. I will I'll move on because that's a fantastic point. So this is our general cost effectiveness formula. Looks a little bit imposing, but it really breaks down to the bottom part of it, which is the conventional cost of traditional natural gas. We use conventional natural gas in this term, being versus the cost of renewable natural gas. If the cost of conventional natural gas is more expensive than the cost of renewable natural gas, a project can be considered cost effective and it should be acquired. If not, it may want to be considered other regulatory exceptions. So the conventional natural gas element's pretty simple. It's the price of that traditional natural gas plus any variable costs that we may see, and that has to do with, let's say, our upstream pipeline transportation capacity. That could cancel out if the RNG project that's being evaluated is an off-system RNG, because presumably, or if it's environmental attributes, because in both of those situations, we would still need to flow molecules on an upstream pipeline, so those costs would cancel. But if we were comparing, let's say, a on-system RNG project versus traditional natural gas, then there is a cost of transporting that gas on the upstream pipeline that can be evaluated and added on to the traditional natural gas while not added on to the RNG. That creates some value there. So that's how the conventional, and then it's multiplied by the quantity of the daily quantity of decatherms that we're looking at acquiring, summed up every day for 365 days, or the number of days in a year. The cost of the RNG basically looks at the annual investment, or maybe usually it's just a one-time investment that we are required to purchase to procure that RNG resource. Some projects we don't end up having to invest in, once again, such as those environmental attribute projects, in which case this value would be zero. It also evaluates the upstream, so we back out any upstream and downstream avoided costs. that may be applicable to this process. Once again, so we got to look at it on a case-by-case basis. So for instance, the commodity portion of it, of the avoided cost, would not apply here because we're already accounting for that by evaluating the conventional natural gas. We'd have to back it out of both sides if we were to do that. But in the distribution costs may or may not apply here, once again, depending on where that gas is actually purchased. And then from the actual valuation of the I guess the attributes, what we're really looking at is the price of that attribute portion of it, plus any variable costs if you do have to go ahead and transport it on an upstream price line, minus the CIF or carbon intensity factor. So this is a tricky one. This ultimately, when we first developed this model, there was some talk about different types of RNG projects having some type of impact on what the value of that RNG is. The best example being the difference between, let's say, a dairy farm and a landfill. RNG from a dairy, by some perspectives and some studies, the RNG attributes from that might be more valuable than, say, from a landfill because it mitigates more carbon from being, or CO2e from being emitted into the environment. In Oregon and Washington, it seems like, I think it's pretty finalized on both ends that it's going to be just a 1-for-1. RNG is RNG is RNG. So instead, that carbon intensity factor just basically accounts for what is that offsetting price of carbon mitigation. So once again, whether it's that marginal abatement cost, so it's whether it's the cost of CCI offsets or allowances, auction allowances in Washington, it looks at what that next marginal cost would be as that element of it. And then once again, multiplied by quantity for each day in the 365 days to get you that all-in RNG cost. Go to the next slide. So some key inputs. When we're running this model, we want to be able to have the flexibility to toggle a number of different things. I'll kind of skim through each of these pretty briefly. The case/RIN selector is one tool that we can use to say, how do we want to evaluate those attributes? Once again, right now, for the most part, we really want to look at that marginal abatement cost, but it could be the cost of RINs, for instance. D5 RINs are a type of RIN that has a value on a marketplace if we weren't needing to use those for our compliance, for instance. We also want to look at the state jurisdiction. That's going to be important when we're trying to figure out what the impact to revenue requirement is. If we're looking at it as a system resource, for instance, that's a larger pool that of rate base that may ultimately lead to a lower impact to revenue requirements versus if it was just looking at an Oregon only project that's a smaller rate base that may have a higher impact to revenue requirement. So that's something when we present this analysis to our decision makers, we show it both as a system resource and as an individualized state resource based on where we think that state, what state we think that project may ultimately be for. Obviously, project term is important and the projected outputs. The output percentage lets us identify how much of it are we going to get. So we've had some projects in the past where a developer has said we're going to do a 50-50 split for it. So that would be 50%. The importance of that is the other 50% presumably would still flow if it's an on-system project. It would still flow through our systems, and there is some value that we would be able to capture from that we need to make sure that we're including as part of this valuation. That's going to be theoretically a transport customer for us, someone that's going to use our system to flow those molecules. We're going to get some type of compensation for that we need to make sure that we're accounting for. Anything that we obviously flow is going to be us, so we're not going to receive that transport compensation for that. So that's not something that we would account for. The supply price, that's in dollars per therm. And then the investment percentage. So sometimes, we have $3 million in this theoretical project that I just kind of put random inputs into, but sometimes we'll have what the investment is, and sometimes we'll want to be able to toggle what that investment is. Maybe if we only invest half in it, they may be willing to do the project, but do it at a higher price. We can toggle these inputs to be able to see what the impact on us doing maybe a lower investment, but the price going up, or we do a lower investment, but they're going to add an inflation escalator to it. By having those easy toggles, it allows us to run the model up more smoothly and see what the impact is to those changes. Type of carbon treatment isn't so as important anymore, but we like to still have it in there just in case that ever does come back. We want to kind of identify what type of project it might be to see what that impact would be. We also, if there's any kind of risk related to the value of the attributes, we have that. Typically, we don't change that though. But if it was, maybe there was uncertainty about the attributes, if that was something that would matter, we can go ahead and classify what that is with that risk rating. And then the escalator, that's important too. We're seeing a lot of projects where we talk to people and they may want us to have some kind of exposure. They might want to protect their exposure by putting some kind of tie to inflation in case. Sometimes it's just a custom escalator. Sometimes it's maybe 50% of inflation. Sometimes it's maybe just 2%. But we want to be able to identify in this model, is there going to be any kind of inflationary impact to that price variable? And then once again, that's something we can toggle if that's still a negotiated value. So then we can tell our decision makers, for instance, hey, if we're willing to pay a little bit more upfront with what we're projecting inflation impacts would be over a long-term present value calculation, it actually may be beneficial for us to do that, or it may not be. We can get that calculation and see what that impact might be. So ultimately that ends up in these values, the non-blue box values, what the impact in terms of dollars and percentage to revenue requirement might be, and what the potential market value or the enterprise value, so that's just the net present value of the project, what it's ultimately going to end up costing over the entire planning horizon. This instance, for instance, would end up being a -1 for this example. But this is so this is just a theoretical example that we just slapped together. So we've already talked a lot about this, so I'm not going to spend too much time on it, but basically we do have different models that allow us to evaluate purchase versus build decisions. Philosophically, they're the same, but the build model has a bit more of a breakdown of some of those items related to ownership that Kim and I kind of touched on in brief. And ideally, we'd like to be able to evolve that model in the future to maybe allow for some stochastic analysis related to some of those inputs. The purchase model, as I already said, it considers any revenue that we might earn from transportation agreements for RNG that we wouldn't own. Once again, example being, let's say we had a project, we only owned 50% of it, the other 50% of the molecules, we may get transportation revenue for. So some future considerations, I think we've already talked about a lot of these, so I won't spend too much time. That risk reduction value I kind of talked about already. Now that we're starting to see a positive risk reduction value in our avoided cost, that's something that we're going to want to incorporate as an RNG benefit moving forward when there is cases of that certainty. We talked about the stochastic analysis already, and then that CIF factor to include marginal compliance costs. That's something we're already moving towards. To make sure that when we're evaluating those projects on a apples-to-apples basis, we are accounting for compliance with the various regulations that we have. I think that's all that I have. If there's no other questions, I will hand it off.
Thank you. Just to talk quickly about our voluntary RNG offset program and where we're at on that project. So an important piece of our decarbonization framework is going to be the establishment of this voluntary program. And we have been making some progress behind the scenes on getting everything set up so that we can have a successful program once we do get to the point of launching it. So the first step has been to do some internal restructuring to staff the program. And as Monica mentioned, we're currently in the hiring process for a manager position. And that person's going to have responsibility for the final development and implementation of the voluntary program. They're also going to be responsible for oversight of our low-income weatherization programs, and then also serving as the point of contact for our work with ETO. So that'll be an important piece in the puzzle. Kind of simultaneous to that, we've been working on a plan to secure RNG resources or attributes that will support the program. And then after these two important pieces are in place, and we kind of have the program outlined, our next steps will be to work with our IT system and billing systems to make sure that we can handle the work of implementing the program. We'll also plan to have some stakeholder meetings to get feedback on our proposed program. And then the final result will be actually filing the program and associated tariff filings for collection mechanism and that sort of thing. So that's kind of a quick update on where we're at on the program. There hasn't been a lot of externally obvious work, but a lot of work going on behind the scenes. JP, I see your hand up.
Yeah, thanks, Lloyd. So what do you see as the relationship between the voluntary RNG program and the CPP in Oregon? Lines there.
Yeah, and that's actually part of what we're looking into right now as we work on developing the program. So I think it's an important piece for customers. There's a lot of our customers that have, especially on the, like maybe on the commercial side of things, that do have their own climate reduction goals. And so maybe they're a little further ahead of reducing their carbon emissions than the CPP would require, or they want to be further ahead. And so to the extent that we can provide some voluntary RNG to them, and it will help them reduce their carbon emissions, it will also help us, from a system perspective, reduce our CPP compliance requirements. The one tricky thing that we've kind of been batting around is how do you make sure that customer isn't paying twice. So if they're voluntarily offsetting their natural gas usage with RNG, for example, they probably shouldn't have to pay on that amount of usage, any kind of fees that are associated with CPP compliance. So it's sort of in the weeds, but that's one of the things that we're trying to work through as we set up the system and develop those billing processes. Did that answer your question?
Yeah, thanks. I think there's probably more to explore here, but it's just an intro. So set up a sidebar conversation with everyone.
Yep, that sounds good. So the other thing that I wanted to touch on today a little bit was hydrogen. And when we think about RNG and hydrogen, those are going to be two critical components in meeting the dual goals of decarbonizing our energy pipelines while still maintaining the benefits of reliability and resiliency that are provided by our distribution system. And if you think about it in the same way that wind and solar resources are helping to decarbonize the electric distribution system, RNG and hydrogen are going to allow us to decarbonize the pipeline system. And there's so much research and development that's currently underway and kind of right at the cusp of kicking off in the hydrogen space that we could probably talk about this topic all day, but I'm just going to try to provide you a very high-level overview. If you'd like to dig a little bit deeper, I've provided some links in the slides for this presentation, and then I'm happy to answer any questions today, or if you think about them after the meeting, we can talk about them further. So probably the biggest news in the hydrogen space is the Department of Energy has launched the hydrogen shot, and it has a 1-1-1 goal. And the goal is to reduce the cost of clean hydrogen by 80%, so to $1 per 1 kilogram in 1 decade. And just for perspective, the current cost of hydrogen is about $5 per kilogram. So some significant work to do, but with the Department of Energy behind it, it feels like it really has some momentum at this point. So one of the first one of the first initiatives of the hydrogen shot is the hydrogen hubs. So the Department of Energy has released a notice of intent to fund the Bipartisan Infrastructure Law's $8 billion program related to the development of these hydrogen hubs. And it will develop regional hubs across the country. And these hubs will include demonstrations that include the production, processing, delivery, storage, and end use of hydrogen. So working the kinks out of all things hydrogen from production to end use in these kind of incubators that will then allow us to develop those projects at a more commercial scale across the country. We're expecting a funding opportunity announcement in September or October. You know, we're pretty well into September now, so I'm hearing that it's probably going to be October is more likely, but expecting some news on that soon. Next slide, please. So in addition to the work that's being done by the Department of Energy, there's also a lot of hydrogen research that is being conducted by industry currently. Cascade's sister company, Intermountain, has long been a member of the Gas Technology Institute. GTI is a research organization. It's made up of member companies, and there's two main sub-organizations under the GTI umbrella. The first is OTD, and they conduct research on pipeline operations. And the second is UTD, that conducts research on end-use equipment. I sit on the board of directors for the UTD arm of GTI, and it's been really interesting how quickly hydrogen research has ramped up over the past 2 years. I'm going to share some publicly available information today, but this is really just the tip of the iceberg of the amount of research that's currently in process. GTI has also partnered with EPRI in the development of the Low Carbon Resources Initiative. And this is a 5-year collaborative, and it's supported by both electric and gas utilities, which I think makes it really uniquely positioned to be able to figure out how we're going to provide energy over the next, decade to 4 decades. And their work is in advancing the technologies that are needed for deep decarbonization within the next decade so that they can be deployed in that 2030 to 2050 kind of time frame. And then when we look at GTI specifically, they've developed or kind of combined all of their hydrogen work into a hydrogen technology center. And it's working on some cross-cutting research, product development, demonstration projects that are focused on clean hydrogen production, storage, delivery, and end use. And I have a couple of examples on the next slide. If you use that link that's included on this slide, you can go and look at all of the research that is publicly available and that they're kind of ready to talk about. So that's a resource if you want to dig further. Next slide. So a couple of examples that I wanted to share today from that site. The first is the Hydrogen at Scale in Texas and beyond. And this project is a joint venture between the Department of Energy, GTI, Frontier Energy, and the University of Texas. And that project is looking at, it's kind of a prototype for these hydrogen hubs that the DOE is working on. So it's looking at designing, building, and operating one of the largest collections of renewable hydrogen production and end-use technologies ever assembled at one site. And this hydrogen energy network is going to help pave the way for the eventual build out of hydrogen hubs by demonstrating their use in an integrated system there around the Port of Houston. The proto hub includes multiple clean hydrogen production technologies, such as the conversion of RNG, wind, and solar into hydrogen. And the hydrogen end use demonstration includes things like power generation, passenger vehicle fuel, and marine fuel. And then the second example that I wanted to highlight is assessing hydrogen compatibility in natural gas infrastructure. The detailed consequences of mixing hydrogen with natural gas throughout the North American natural gas distribution system is really important for maintaining a safe and reliable network. And so the work that GTI is doing in this project is assessing the corrosion and hydrogen embrittlement mechanisms that are associated with blending hydrogen, and then looking at the impact of hydrogen blends on end-use equipment. And GTI has completed an in-depth analysis of the key issues related to blending hydrogen into the natural gas pipeline system. This analysis has provided a framework for the issues that GTI and others are currently studying. And I'll drop a link directly to this study in the chat. But some of the research or some of the findings are that 20% or less blends will result in a minor risk increase. Over 50% results in a more significant increase in risk. And GTI has done some testing on the impacts of kind of that 0 to 30% hydrogen blend on end-use equipment. And the results of that work are promising for the ability to blend up to 30% hydrogen with little impact to end-use equipment. So some really interesting work that's going on to be able to make the integration of hydrogen successful. GTI is also doing the important work of assessing the impact of hydrogen blends on pipeline materials and systems. And an important area of focus is on what levels of blending require no change to the existing system, and then at what level we'd need to do some retrofitting. And one of their key initiatives is also to do the research necessary to develop hydrogen monitoring systems. So the hydrogen molecule is smaller than the natural gas molecule or the methane molecule, and so looking at what we would have to do to be able to better monitor hydrogen in the pipelines. I've also heard of some work that's being done. This is kind of beyond the work that was done in this particular GTI study, but some work being done by private companies to develop coatings that can be applied to existing pipeline infrastructure that would allow for up to 100% hydrogen transportation through existing distribution systems. So that's an interesting area of research also. And then finally, GTI is also looking into monitoring systems that may be necessary or the upgrades that might be required for end-use equipment at higher levels of hydrogen. So kind of beyond that 0 to 30% range that looks like it's okay with the current equipment. What is the next level going to require if we were to use higher levels of hydrogen? So there's a question I see in the chat. What are your thoughts, if any, on the findings on injecting hydrogen into natural gas systems issued by the California PUC? This independent study found hydrogen blends of more than 5% could require modifications of appliances to avoid leaks and equipment malfunctions and increased emissions of nitrogen oxides. I think that all of this work is really important, and that's why I think the work that GTI is doing in the laboratory, and then they're also trying to do some work in some actual real world settings. And I know that they've done some work in California as well. It's all really important to try to figure out what those pain points are, and then how do we address those. So if the California study found that anything beyond 5%, we would have to implement some new potential retrofits or new leak detection. I think that that's the kind of research that we need to do, and the kind of information that needs to come out. And then not just what are those percentage points for blending that's acceptable, but then how do we get to the next level of blending, that eventually will allow us to get to 100% in some of our distribution system. And Monica also dropped in the chat that NIA is working on a scoping study that's looking at the effects of hydrogen and mix on efficiency of natural gas equipment. And Cascade's funding that scoping study for the Northwest Energy Efficiency Alliance. And I know that NIA also works a lot with GTI and leverages, so they've been a great partner in leveraging the work that GTI does and then implementing that actually into field demonstrations and trying to see how that laboratory research actually works in the real world. And that's the air quality. So Kara dropped the study into the chat, and then wondering about the necessity of air quality monitoring in homes that are receiving these blends. So that's some of the monitoring work that research that's being done. So not just on air quality, but also on safety and leak detection, right? We need to be sure that if we're blending hydrogen, we're able to also detect the hydrogen molecules in our leak detection systems. So yeah, there's a lot of important work to be done in the hydrogen space, but I think it's very exciting. It's an exciting new development in energy delivery, and it's going to be important in reaching our climate goals. Any other questions? Okay, Brian, back to you.
All right, thank you. And I'm going to pass it off to Kent to talk about our RNG development status.
Thank you, Brian. My name is Kent Krause, and my key responsibility here for the company is the ground level development of renewable natural gas and hydrogen projects in Washington and Oregon. And before I jump into my presentation, I wanted to answer the question that was asked earlier, because it was an interesting one about the amount of energy, if I'm understanding the question right, the amount of energy being put into the RNG process, scrubbing process, the process to clean the gas up versus what's coming out. And also I think Kathy had questions about emissions. And I want to talk specifically about a couple of the projects where we've worked on the scrubbers up front, where it was involved in that sizing, and I have that electrical data. So I did sort of take a look at that because that's a great question. But based on two different projects that both used the membrane style scrubbers, they have no combustion going on in them in terms of the gas processing part. Everything that's operated inside is run off electricity. It's all scrubbers and pumps, etc. The only combustion that goes on is if for some reason the gas doesn't meet quality and it's flared. And one of those facilities is actually recycling that gas for boilers. So this would only be occurring if the gas didn't meet quality, and that's usually for a short term while whatever is causing the problem is addressed, just like any other process operation. But from an energy standpoint, in terms of what it's consuming to create it, a single train unit is only consuming, it's basically 4.5% roughly in terms of the electricity that's using versus the equivalent amount of energy output. And to put that into electrical comparison, it would be a 700 megawatt on an annual basis, 700 megawatt hours over the course of a year for input and 15,000 megawatt hours in output. If it did have to have a second processing train, as one of these projects did, it would be about double that amount. So it would be about 1,400 megawatt hours a year in energy input versus the 15,000 out. But either way, you're somewhere between 4 to 8% in that energy. And then just to go back to Kathy's question, it wasn't so much this case, that second train isn't required because the gas is dirtier. It's generally required because the nitrogen and oxygen levels in the cleaned up RNG are above our pipeline quality spec. And that's one of the biggest challenges that we see, regardless of the type of gas, including landfill, is trying to get the oxygen and nitrogen levels down to our pipeline quality. So anyway, that's kind of in deep detail, but I wanted to answer that question before I even got started. I hate leaving it undone. It's a good question. I'm going to talk about, go ahead, Brian, you can advance the slide. We currently have 14 RNG projects in development and 2 hydrogen projects. I'm going to talk only about the RNG projects, and the numbers are slightly off because this is a very active industry right now, and we had a couple of projects that were on the periphery that we didn't consider real that have gotten very real in the last week and a half or so since this presentation was last checked. But I'm also going to try and avoid confusion. The projects I'm going to discuss are basically 2 types, and Devin has kind of touched on this a little bit, but I'm using the term purchase a little differently than he did in his presentation. Our first priority is doing on-system RNG development on projects where we can actually purchase the environmental attributes as well as the gas. And our primary, reason for wanting to do that is to use that gas to use for our voluntary RNG tariffs. That's sometimes challenging because of pricing situations. So I'll talk a little more about that. And Devin has also touched on that as well. But right now we have 4 projects in active contract negotiations. One of those projects is I'm working on execution documents today. We also now have 3 projects that are purchase projects that are in early development. On our second priority is again doing on-system RNG development, but this time for transportation only projects. And these are cases where the gas is too expensive for us to purchase economically or for it to make sense for us to do that. And that's typically dairy in most cases where we're working with. We have one of the reasons that we don't want to purchase that gas. I think it might have been alluded to here is about $30 a decatherm, but the dairy developers I've been working with, when we talk about purchase, they want $60 to $70 per MMBTU for their gas, which is 4 times what the D5 gas is going for most of the time, or that we feel like we can be competitive enough to obtain. So it's not a good economical decision. We don't feel to go after that gas. So those projects, and in most cases, they don't want to sell it to us because the deep carbon intensity of that gas makes it very valuable in California and other fuel markets. So we are trying to support those projects as best we can to help them get that gas on the system and displace natural gas with their RNG. We have one of these projects that's already under contract. Another one that is at the very, very tail end of contract negotiation, and 5 other projects in development currently. Go ahead, Brian. Looks like I've got a question already.
Yeah. Yep.
Yeah, if it would be okay if you go back to the past slide.
Mm-hmm.
I appreciated how you explained the priority to on-system RNG development. I just would be really cautious. This slide suggests that the projects are displacing geological gas, but if you don't own the renewable thermal credits, if those are being sold elsewhere, it's not displacing anything really, right? It's just brown gas. Somebody else owns those environmental attributes. So I just would be really careful to, caution you about making sure that you're using pretty accurate information. So there's no double counting, no presumption that Cascade has its own RNG flowing on the system if it doesn't have the environmental attributes.
I'm not trying to make that claim. I'm just saying that we physically are, on a physical level, we are displacing the natural gas on the system with the RNG and supporting that process, which is What we
Sure.
can do when we can't afford to buy.
Yeah,
it.
when you explained it, you definitely said that, you know, that you're displacing with their RNG. And I just would say maybe edit this slide so it's clear you're displacing their, you know, it's just brown gas. You don't have the environmental attributes.
That's true. That's absolutely correct. Yeah. Okay. Because of the confidentiality involved and the competitive nature of RNG, we're referencing most of these projects by the county they're in rather than being specific at this time. That'll get a little more specific as time goes on, and these things are further under contract. But if you're wondering why they're mentioned in terms of county, that's why. The first project I'll mention is sort of we can get specific about. It's out in the public eye already, and that is the Deschutes County landfill in Bend. They put out an RFP to take their gas that was being flared from the landfill and to try to find a way to use that and put that into useful energy. Cascade and Jacobs Engineering partnered on this to respond to the RFP, and we're the successful candidate. And they're currently designing, and we will own and operate the processing facilities at the landfill to scrub that gas, and we will put it onto our distribution system there locally in Bend. We operate a facility in Billings, Montana that is very similar to what we're proposing to do in Bend, and it's been in operation for 10 years now. We're currently working through some landfill operational and contractual details with Deschutes County. We're going to be adding some more vertical wells there to help process more of the gas that's underneath the landfill. We're looking at about 2.5 million therms a year. It's a 20-year agreement currently. The next project I'm going to mention is it's a more complicated project because there are actually two facilities involved, but it's one developer and it's one project as a whole. One of them involves a city landfill, and the other is a food waste manufacturer that has a digester operation, and we're going to combine. There'll be actually two separate interconnect facilities and processing facilities coming onto our distribution system. This is going to be injected into our local distribution system in two different places, and it's a total volume of about 1.25 million therms a year. It's a 15-year agreement, and I'm actually today working on the execution documents for this. So this will be under contract before week's end. So both parties have come to terms. So this is our first actual environmental attribute purchase project. So we're glad to be getting this one completed and moving on to engineering and construction. Go ahead, Brent.
Kathy, do you have a question?
Oh, sorry.
Yeah, I was just wondering okay, you're putting the RNG on the local distribution system. Is most of it going to be used for local concerns, or are you basically piping it someplace else?
It's a good question. The gas will be made available for our tariffs, for our RNG. The way the RNG will be displaced to customers will depend on the customers who want to sign up for it. So regulatory will make this gas available to our customers once it's actually on the system. And then those customers that desire to use it can subscribe to our RNG tariff, our voluntary tariff, to purchase RNG to use for their homes. So the physical gas will stay on the Bend system, but the environmental attributes will be tracked to whomever is using those for their signing up for the tariff and using that actual RNG, if that makes sense.
So that's kind of equivalent to what we do with the RECs, but buying up the RECs from our utility.
That's exactly the same, because we'll be generating RTCs with this instead of RECs. So it'll be the same type process.
Okay, I'm learning a lot.
Me too.
And sorry, Kent, could I ask one question? So both of these projects will be Cascade owned RTCs that will then be transferred to the voluntary program participants, both of these, Deschutes County and Benton County?
Yes.
Okay,
yes,
perfect.
Okay, Brian, you can go ahead.
Okay, this
The next
Kent, Kent, this is
Yes.
Abby. I would just also note that those would be utilized for compliance with CPP as well. Or in some cases, it could be utilized for compliance with these direct ones, for compliance with the Washington rule as well. Those are some of the complexities we're working through with determining how to use the different compliance options of RNG with the different rulemakings. So
Thank you, Abby. This next project is actually another food manufacturer, and we are going to be capturing waste from this facility to generate RNG. Oh, I'm sorry. I'm on the bottom part of the line. Let me go above. The next project is a municipal industrial food wastewater project. And this particular project is an aggregated site. There are 6 different food producers and manufacturers that are where their wastewater is being collected into a central facility. We are working on both the purchase and interconnect agreement for this system, and it's moving along rapidly. It's the largest RNG project that we're working on currently that's highly active. And this would also be injected into our local distribution system. It's 3.4 million therms a year, and this will be, it says 15 to 20 on the slides, but this will be a 20-year agreement the way it's shaping up right now. We're kind of getting down to final terms on it. And the project below, which I started talking about, is another food waste, direct food waste project. We're working directly with the customer on this project, no third party involved. We've been kind of involved in this since conception. It's a 700,000 therm a year project, 10-year project, and this is going to be injected onto a smaller distribution system in Yakima County. Go ahead, Brian. We have a project that's under contract, a transportation project. Those were all previously, those 4 I just mentioned were all the purchase projects that are in an advanced stage. We do have a project under contract in Cowlitz County, Washington. This is another aggregated waste site that we worked with from the very start. We actually worked with them to site it on our system in a place where we could handle the waste and to help facilitate their process. They're actually a national firm that aggregates food waste and other types of waste from operations. And they are taking waste from 100 grocery stores in the Washington, Oregon area on the west side and processing this in one facility. It'll be basically a 24/7 operation of, food waste from these groceries coming in and creating RNG. The engineering process on our side has begun on this. It's 1.8 million therm a year project. They were hoping to start in Q4 23. I feel like this will slide probably at least to the very beginning of 24, but it is moving forward. We also have a dairy RNG project in Snohomish County, Washington, a transportation project that's very near execution on contract. It's a 3,500 head dairy, and we have an interconnect agreement just on this facility. It'll be 815,000 therms a year. This also was projected to start at late in the end of last year, but it's going to slip at least until the beginning of 24. We'll see how that works out. There's been a change in ownership. That's one of the reasons we've had a couple of months delay on it, but it's moving forward now. I've got a question about these being transportation projects. Yeah, the 2 slides that are up right now are transportation only projects.
And I guess I should just clarify for my own benefit, that just means you're transporting. This isn't for transportation fuel.
Yeah, no.
Right, okay,
I'm sorry.
I figured.
We do not have the environmental attributes on these. We never had a chance with either one of these. These projects came, as once in a while they do, with a buyer already in place before the projects ever come to us for development. Even though in the case of the Cowlitz County project, we were involved in the project at the very beginning trying to site it. We were never able to even compete to try to purchase those attributes. So we're just supporting them and getting it on the system. Thank you. Next slide, Brian. Just one last comment. There's been some things I've read where people say that RNG projects don't make a significant difference. They're too small to make a difference, and they'll take too long. But I want to say from the standpoint of a company like ours that serves a lot of secondary cities, 4 of the projects that I just referenced will displace near 100% of natural gas, the traditional natural gas consumed on that system during times of low usage, which is kind of a key thing in terms of designing facilities. You know, we can't onboard consistently more than that level, but these single projects will offset the base load basically of our gas system. And, you know, and we're very early in this process. And 2 of these projects are in pretty significantly sized secondary cities. One of those is Bend. So RNG can make a difference. We just have to get going and keep moving on it. So thank you, and I'll answer any more questions if there are any.
All right, thank you, Kent. If there are no other questions, we only have about 5 or so slides left. So I'll go through those very briefly and then we can let everyone go. Thank you for sticking with us. It's gone a little longer than I had expected, but that's mainly because we've had very good questions and dialogue and back and forth conversation. So really appreciate that. So we'll jump into the preliminary results that we have currently. So when we remove emissions and we take a look at our transportation, our upstream transportation with the pipelines, we're currently looking at a shortfall in the future. In Washington, we have zone 11. We're looking at a shortfall in 2034. This is before we apply any DSM. And then for zone me Washington, this is kind of central. This is the Walla Walla area and GTN. So the Walla Walla area can now get gas off of the GTN pipeline. And so we kind of lump those together since there's transportation contracts that can go to either one. And that one sees a shortfall in 2038. When we include DSM, it actually pushes back the shortfall that we see on transportation out to 2046 and 2049. So that kind of shows the impact that DSM can have. I will make one note that DSM does have a bigger impact in terms of the length of the delay when it's out in the future because of that cumulative effect that DSM has. If the shortfall is a little sooner, it may not delay it as far, but that is the benefit of demand side management of delaying these projects. And I see JP, you have a question?
Right, super simple question. I should know this, but don't. Zone 11 is what?
Zone 11 is I believe it's the Tri-Cities area up. There's a little lateral of.
Ryan, this is Chris.
Yes.
Our gas supply. Zone 11 is the Yakima lateral from Zilla up to Quincy or Wenatchee area.
Okay.
And then so the area in Oregon is GTN, right?
Yes. So GTN is that Central Oregon. It goes down through Redmond and Bend and Gilchrist and all those smaller cities, Lapine, Stern, Sun River. Yeah. And that's GTN.
So you guys are just to make sure I'm reading this right. So in terms of the upstream pipeline shortfall, where you guys will have needs to be met without DSM 2038, with the DSM in your IRP that you guys are planning on getting, or is this, what is that? What do you mean? What is DSM for you guys? Is this additional DSM or is this the DSM